Hello and welcome to this exciting tutorial where you learn MySQL from zero to hero. So I'm going to imagine that you don't know anything about running queries on MySQL. So we're going to start from scratch and get you up to speed until you get to do more advanced stuff, right? So if you already know some basics on MySQL, you can just skip the video to a particular timestamp. Things are labeled in there in the timeline. You can just skip to what you want to watch. Or if you don't know anything, just start from scratch. It's always better to start from zero. That way, because we are building up to something bigger, you can learn more like that. All right, so the importance of a database is that even when you are running your website, what you're really doing is just manipulating the database. So even when you are browsing your Facebook, what you're doing is manipulating the Facebook database, because you're reading from there, you're writing from there, you're updating records, and you're deleting some stuff from the Facebook database. So that's very powerful stuff. If you can learn how to run queries on a MySQL database, then you are unstoppable, because what all websites really are just database manipulators. All right, guys, so to begin with, we must have a database to manipulate. And so we're going to use MySQL. Now, what exactly is a database? So a database is just a set of, a collection of organized information or structured information which you can read to, write to, and manipulate. So MySQL is what is known as a relational database. And what that means is that data is organized in rows and columns, kind of like what you have with Microsoft Excel. So in Excel here, for example, you have these columns and these rows here. So you can think of a database as something like this, where you name some columns and then you have rows that you can insert in those columns there with those column names. And so you can have a bunch of information here. Maybe this could be a user's list, where you have first name, last name, gender, and so on and so forth. So this is how you should imagine a database in your mind, a database table. So each table, you can have as many tables as you want, and each table is kind of like a Microsoft Excel sheet over here. So you can add more sheets to have more tables and so on. But the beauty of a database is you can organize your data in such a way that you can mix between tables, connect things together, delete, edit, because the database information is useless if you cannot edit and manipulate it later on, or you cannot read from it. So we have to know how to do all that after we save our information. So in order to have MySQL here, you would have to go and download MySQL from the website here. However, I didn't use this method, but you totally can. However, I installed XAMPP instead, because it comes with three things: MySQL, PHP, and a Apache server. So those are things I like to use often. So instead, I installed XAMPP. Now, XAMPP may not work for all systems, even though it should. Yeah, it should work for Linux, Windows, and Mac. But if you have a Mac, I think you should install MAMP instead. If you have Linux, you should install LAMP instead. Just replace the X with a L and M for Mac. I think the rest, Windows, XAMPP will work just fine, or if it doesn't, you can use WAMP instead. Alright, so once you download this, download 64-bit or 32-bit, depending on your system, and then just install it. Once you install this process, the install process is pretty straightforward. You don't have to suffer there. Then you're going to have a control panel once you install. So you can just go to your start menu, open that XAMPP control panel, and then just make sure that your database is running. And you can make sure it's running by just clicking the start button on one of these. So in my case, I have the server, which is Apache, that's running, and MySQL as well. We don't really need Apache running, it's just that I use it often, that's why it's running here, but just make sure MySQL is running here. Now pay attention to the if you go the MySQL route like this, it will ask you to enter a username and password. So pay attention to those details because you will need that username and password to actually connect to your database. In the case where you install with XAMPP, the username will be root and the password is left empty, but you can always change those things by just typing, making sure Apache is running and MySQL is running. Then you can type localhost PHP myadmin like this, and this will take you here to where all the databases are. In my case, I have hundreds of databases here on the list over here due to so many projects that I do, and in your case this might be empty. So we can always create a new database very easily by going to click new over here, and then we can name our database, and in this case we're going to call it MyDB or something, MyDB, like that. Now you shouldn't put spaces in there, just put an underscore if you need to if you need 2 words there like that. So in my case I'm just going to say MyDB. Hopefully I don't already have that in here, and then I can click create to create a database. Okay, so there it is over there. Cool. Now we are using this UI which comes with XAMPP, and sometimes you may not have this, especially if you just install MySQL directly. It may not come with the PHP myadmin here. So we will see how to actually manipulate things from the command prompt, because a lot of times if you are given a task to manage a website that has a dedicated server, it's not shared hosting, it's just a dedicated server, which means the owners of that server have the right to install whatever they want on that server, and usually they don't install PHP myadmin like this because it makes it easier for people to manipulate the database. So instead they'll have just a command window which they use to manipulate their database. So we're going to be using that so that in case you have a situation like that, you are able to do things to work, right? Also, it helps you understand the queries a little bit better when we don't have this GUI here, because this does a lot of background work for us and it makes us lazy. So it's a good idea to use the command window, and we're going to go in that direction eventually. So to start with here, you can create a table. So let's create a very simple table here and see what's going on. The few things I want you to see here. The PHP myadmin window here, the GUI, is good for when you are learning, but eventually you have to try and step away from it and try to write queries on your own. So we're going to use this just to demonstrate that you can learn to do things using this tool. So I'm going to type users here because I want to create a table. Here currently there are no tables, that's why there's a minus sign but no plus here. So we say users here, it'll ask you number of columns. Let's just leave it at the default and hit go. Now this doesn't create the table yet, but it's asking us what columns we want. Now usually we will have an ID column as the primary key. Now the primary key is used mostly to search for records. Without a primary key, this serves as a unique identifier to each row. Just like you would have in Excel, you have these numbers over here that are used to identify a very specific row if you want to point to it. So these numbers here are in sequence, ideally. That way it's easy to find a specific number if you want to. So we can tell the database that we want an ID column here, which will serve as that. Then maybe we want the first name. So I'm going to use an underscore. Do not use spaces with column names, though I think you can, but it's not a good idea. So let's just use underscore there. So we're going to say last name as well, and let's just put one edge here. Okay, so with the ID here, we want these to be numbers, so we're going to leave it at int, because int stands for integer, which are numbers, and if you hover on these, it shows you the range of numbers that you can get from this, right? So int has a length value of 11, which means this can hold 11 digits. As you can see, if you hover on this thing, if you count those, that's 9, 10, right? So if you count the numbers here, the limit that it shows, you see that it's actually 10 digits, okay? 10 digits. However, this thing can hold more than that because these are just positive numbers, but they're also negative numbers of the same value here. But if you put a negative sign, so initially it holds 10 digits, right? But then you can hold an extra digit to show whether that number is positive or negative. So that makes 11 digits in total. So if the first number or the last number is 0, that means it's a positive. If it's 1, it's a negative or something like that. So that's called a, let's see here, the attributes here, right? There's the unsigned and signed versions. So the signed version means it can hold negative values as well. Unsigned means it can hold only positive numbers because that negative is a sign. So if there's no sign, then it's positive, right? Which means it's unsigned. So if you select here and say the numbers I want here will be unsigned, which means you can only hold positive numbers, which means the length goes down to 10 like that. Now you don't need to fill this in, it can do it for you because it knows when you say unsigned, the limit is 10. Right? So when you specify that this is signed or unsigned, you're only saving 1 digit, right? So it's not really that important. I've seen people obsess over this, but you don't have to do this, but you can do it if you want. You're just saving 1 digit there. All right, so here we're telling it that we are only saving positive numbers, and this is an integer. The length will be filled in for us. And here you can put a default value if you want. You can say this can hold a no value, which is an empty value, or you can define an actual value here. Maybe let's say 0 is our default, but we don't need that here, so we'll leave it at none. Then very important here, there's AI, which stands for auto increment. So we're going to click that. What that does is it tells the ID that it should add a number automatically to the ID column. Every time we add a row, it will just increment by 1. This is good, so you don't have to worry about adding these numbers manually to your rows. Okay, so we click that, unsigned, int, we are good to go. Now, if you want bigger numbers, like you want your numbers to be greater, you can use big int here, which goes up to, I think, 19 digits or something like that. But most of the time, you will not need that because 10 digits is insanely huge. So I think you can cover for everything you want there. All right, so age here is an integer as well, but not as large as that because we know that an age, we don't have people that are 200 years old. So maybe we have people who are 100 years old, but 100 is 3 digits. So if we can limit it to 3 digits, because we know that the highest 3-digit number is 999, and we don't have people that live that long. So 3 digits is enough. So the reason we put these lengths here to limit is because we want to save as much space as possible. If the system knows that we only need 3 digits in here, they need to allocate the appropriate space, rather than it expecting this to be 10 digits long when we know that age will never reach that far. So on the first name, this we're going to use var, which stands for variable character, and here we can put a few characters because a name, the limit of a name could be 30 characters, a first name, right? And 30 for a last name as well. Now, if you notice there's text here, we could put text, but text is more for documents, entire documents that you want to dump in here. You can look at this. When you hover on this, it tells you that the maximum size here is, this is quite huge, it's 2 to the power 16, which is a huge number. Where is that? 65,535 characters can be stored in here. That's quite a lot. We don't need that just for a name. So we'll go with var here, which has a limit of, Okay, so has 65,000. So we're limiting it to 30 and just telling it, hey, we just want 30 characters in here, right? But you can go bigger if you want. You can store entire images in your database using the blob, for example. There's also medium text, which is longer, and long text, which is really big. This is like 4 GB or something of data you can store. Then there's also blob here. However, I recommend you never use these blobs, tiny blob. When you reach levels where you want to use blob, you should always just save that data to a file and just put a reference in your database to that file. Because when you have blobs in your database, it makes it really slow to handle. Just never do that. Okay, so last name, first name, there we go. And with this, we should have a proper users table. Now, when I hit the save button here and hit save, you will see that it will, okay, so it creates the table. I was hoping it would show us the query that was run to create this table, but it didn't. However, it's not a problem. We can always just go back to the list of databases, right? We can click here where it says server. So, but before we go there, you can see here it shows you the key, that this is primary key, first name, last name, and whatever you had chosen here, which is good. So now we have a table. If we click browse, there we go. We have a list here, just like kind of like Excel here, right? So we have columns. We don't have any rows yet, but no problem. Now, when I clicked browse, you see that it shows me the query that was run to actually retrieve this information here. So by saying select star, which is all columns, from users, which is the actual table name, then we are retrieving all records. But since there are no records, it shows nothing. Okay, great. We have that in mind. Now, if we go to just open PHP click there, and databases here. So we have a list of databases. Now we go down to my database, which we just created just now. Select it from there. And then what I want to do is with, it says with selected. Oh no, I can only drop here, right? So that is not cool. Okay, so that's not what I wanted to see. Okay, what I wanted to see is the table that I created. So click on the database that you created here, and then select the table that's here, and then with selected, show create. So you click show create, and it will show you the query that you actually need to run to create exactly this table. So this query is saying create table users, and then it gives you the column names and all the properties of that column here. For example, first name is voucher, in brackets there's 30, which means that's the length, and then not null, which means it doesn't allow empty values, and so on and so forth. Age is int of length 3, not null as well. There's no default value, but so. And then there's a primary key ID. This one is considered the primary key. And then there's more details about the type of database and the text encoding here. But you can always copy this, and if you run it, it will actually create exactly this table. So I can actually copy this right now, this text, go back to my DB, and then drop this table. So when you are deleting a table, you say drop table users. That's the query you run right there. So if I say okay, that table is now gone that we created, but I can always bring it back by just going to the SQL tab where I can run queries and paste that query. Now, it doesn't have a paste here, but you can use your keyboard, Control V, and then, or Command V on a Mac. Then you paste this, and then you can run a query here that will actually create a table for you. So if you click there, now we have the users table back. Great. Now, if you want to install data, you can go to the Insert tab here, and then just add some stuff here. Let's say John, for example, like that, and then age, you put maybe 36, something like that. You are given the option to add 2 records here. Now keep in mind that the ID is auto increment, so if I don't provide a value, it simply creates one for me. So that's the advantage there. So let's try and put another one. Let's Mary Jane here, and then age of, let's say, 10. Now if I hit go on any of these, it will save both records. Now if you notice, before we move away, you will see that it created a query to create those records. And as you can see, it says insert into users, and then it has a list of columns here, and then there's values over here, and then the actual values that we want to put in these columns. Now you have to notice that these have to match exactly the same. So ID here is empty, which is null. So if we give a null, it will actually just create an ID for us. And then there's a name John, which goes here, and last name is Banner here. 36 is the age. Now since we're inserting two records, there's a comma here, and then it gives another set of data. Notice that the columns are only shared once, and then you put values over here, and then you can put as many values as the records you want to add over here in a group. Just make sure that the order is important here. If age is at the end here, you have to put it at the end here, otherwise it will think whatever value you put here is representing the age. So this is a query you can run to actually insert stuff into your database. Okay, so now that we have that out the way, if we go to browse, you will see now that we have John here, Banner, two records at least, and the ID has been added incrementally automatically. Okay, now since we clicked browse, it actually ran this query, select all from users. So the star is just like all columns, right? So select from users. So that's the language we use to read and write to databases. Now it can get very complicated very quickly, so we're going to go through step by step and build on these queries to see how everything works. Now let's switch from this and start using our command line tool, because we want to get very good at writing queries. So now that we have a database, we are good to move on to the command line. So whenever you install MySQL, it automatically comes with a command line tool. So we can access that by going to the command window. So you can use any whichever system you're on. There's obviously a command window, because this is like the root of any computer system. This is how you get root access to a computer. So here we want to run the MySQL application. So you can type MySQL, just like that, and Windows will try and find it, or whatever operating system you have will try and find an application named that. So if you press enter, okay, so here it's telling me that access has been denied. So this just shows me that MySQL is actually properly installed. If you get something like command not recognized, it means MySQL was not well installed. So you have to redo the installation process, or maybe you may need to add, you have to find where MySQL is and add it to the environment variables. So if you're in Windows, you can just search for environment. I don't know how to do this on other systems because I've always just used Windows. So you can click on environment variables here, and then go to paths down here. You say path, and then click edit, and then you can add one more path here by just saying new, and then you go to wherever you installed MySQL. You should find that MySQL file, and then put the path to the MySQL file right there. So in our case, for example, where we have installed XAMPP, what we will need to do is, let me see here, with an explorer thingy. So ours is installed inside C XAMPP, because we're using XAMPP, and inside XAMPP there is a MySQL folder here, and there is going to be a bin for binaries, and then right in here we will see the MySQL .exe. So this is the file that actually runs whenever we are using MySQL commands. Okay, so there we go. Now the reason it says access denied is because whenever you're accessing MySQL through the command line, you need to enter your password. It's the same thing with the PHP My Admin. It's just that when you haven't added a username or password, it doesn't ask you for that. So we can do this by saying MySQL like this, and then we say -u like that. That's the flag for user. Now, if you want to know how I know this, you can just type, I think it's --help like this. Okay, great. So once you do that, it shows you all the possible switches you can use here to do certain things. So for example, if we say -u, it's in alphabetical order here. As you can see, it's right there. It says username. So you can either type --user, excuse me, or you can type -u like this. So user for login, if not current user. So you can use that as well. You can also use -p for the password. So let's see here. So don't worry about all of these. We will not be using most of these flags. There we go. Password, and then a --password, and then the actual password to use when connecting to a server. If password is not given, it's asked yes. Okay, great. So this is all good. Let me clear the screen again, and let's type MySQL. I always get confused. So you say u, and then you leave a space and say root like this. Okay. So once you say root like that and you press enter, it will say welcome to MariaDB monitor. Okay, so everything is good. Here it will, now since there's no password, it doesn't ask me for a password. So because I just say root like that, it doesn't ask. But if there's a password, it will actually ask you for a password now here, and then you can type in the password. So that's how you do it. You put that, and then you ask for a password. Now, there are times when you want to add the password directly here, which is unsafe because then your password is in plain text. But here when you're typing, if it's asking you for a password and you want to type the password, it won't show anything, right? So you may think nothing is happening, but just type your password and press enter. Now, let me exit here. You can exit any process in the command line by pressing Ctrl+C twice, I guess. Then it exits. So you can still do it like this, MySQL root, and then do -p like that, so that it can ask you for a password if you know there's a password here. So if I press like this, then it will ask me enter password, please. Now, since there's no password here, I'll just press enter like that, and that's the same process again. Now, if you want to add the password, let me get out of here again. So let's go down a little bit here. So now, if you want to add the password directly, you can do that by just saying -p, but do not leave a space, right? Just type the password. Just after the -p, you can type my password over here, like so. So it will look something like this. Now, I know this is the wrong password, but if you have a password, you can do this. Especially if you're running this as a process that is not, you want to send this password together with, maybe this is run by a script instead of a human. So because if you ask a script, enter password, it won't have the time to do that. So you can do it this way, but then it will say access denied because this is the wrong password, like that. Okay, so those are the ways you can actually access MySQL, but let's do our thing here. MySQL root, like that. Okay, so now that I'm logged in, whatever I type now, as from now, is actually a query to read from the database. So I have access to MySQL, but there's no database selected. That's why you see none over here. So we have to tell it what database to use. And in this situation, we just say use, that's the query to use a database. And our database is something like MyDB, right? and now it says database changed, right? But let's start from scratch. Let's drop this database because we want to create it from scratch. So I'm going to say drop database, and then name the database, right? MyDB. Okay. Now, it's possible that you could be doing this without knowing whether the database exists or not. So you can put an if statement. You say if exists, like that. There's also if not exists for certain situation. So drop database if exists MyDB. Oh, and this is another thing. If you keep pressing enter like this, it will keep going like that because it's expecting more of the text. So I'm going to put a semicolon because this has to have a semicolon at the end. Okay, so there we go. Now the database does not exist anymore. We can go back here to check for it. So if I now open my admin, PHP my admin, wait a minute. Why is it still showing? I want to refresh this. Okay, there we go. Let's go to MyDB and it's gone, right? It's gone. That's how you delete a database, okay? So if you want to see all databases, you just type show databases. Don't forget that semicolon, right? And then it shows you the list of databases that are here, right? And MyDB isn't there. So for now I want to exit this because I want to clear the screen. Let me go back, MySQL u root. There we go. Good. Now let's create a database. To create a database, we just say create database. Now to make sure you don't get an error, we say if not exists, like that. Create database if not exists MyDB. That way if it exists, you don't get an error. So semicolon, press enter. There we go. We've created the database. Now let's use it. So you say use, and then you don't name database, you just say MyDB, semicolon. Now database has been changed. Then you can say show tables to see all the tables in that particular database. Press enter, and it returns an empty set, which means there are no tables in here yet. So let's create some tables, right? So let's create the first table that we created using the PHP My Admin system instead. So here I'm going to say create table. Now the thing is, you can copy and paste text here. So you can do this in a text editor and then just come and paste this information here. So we can do this. Let's go to an editor here because it's much easier to type in a more friendlier environment. So we're going to say create like that. So what I'll do is I'll change the language here. Let me see if it has MySQL at all. It doesn't look like it has. Markup language. Let's see. You know, I've never used this for that. So what we're going to do is let's just put PHP or something. I think because it does recognize MySQL. So I'm going to select PHP here. Let's just say PHP. So if I use capitalized, you know, it's case insensitive. That's how MySQL is. You can use capital letters or small letters. It won't care. You can even do it like this, create. It doesn't matter. Yeah, you can do like that. It doesn't matter at all. It will still work. So let's go. Create table. That's how you create a table. And then you give it a name. So create table users, like that. Now inside brackets you have opening and closing brackets. Let's put that semicolon at the end, right? And then we put our column names in here. So we have an ID, we have first underscore name, we have last underscore name, and then we have age, like this. Okay, good. So with this that we have here, that's a list of columns, but the problem is it doesn't describe what these columns should be. So let's put a type for each column. This one will be an int, right? This one will be variable character. So since I can select two parts here that are the same, I can just type like that. and then inside brackets, let's put our 30 like that. And then age is an int, right, of 3 characters long. Here we don't have to tell it what character, how many, but if we put 10, I guess it will assume this is unsigned, but we can actually tell it that this is unsigned, like so. Okay, so we can do the same thing over here and say unsigned, like that. Okay, good. But we want our ID to be, now keep in mind that this doesn't care about empty spaces, so we can actually do this instead. That way this is easier to read, like so. Okay, cool, like that. Just don't put a comma at the very end here. So we want this to be primary key, so we can just say primary underscore key. We also want this to be auto increment, so we can say auto increment, like that. Okay, now we don't have to put primary key here, as you saw earlier when we saw the create query that was generated by our PHP I can also tab these in like so, because empty space doesn't mean anything really. So instead of primary key here, you could put it there, that's fine, but you can also put a comma here and just say primary key, and then you say ID, like so. Okay, great. Then you put a comma. Now you can also put other keys that are not primary key. So let's say, for example, you're going to be searching by first name for users. So when you have 1,000 usernames or first names in your table, it becomes very difficult to search for a specific one. So you can tell the database to index the same way it does with ID. It can index your first name. What an index just means is that it saves extra data that helps it to search better that particular column, to speed things up when searching. So an index adds size to your table. So it makes your table slightly bigger because it has to save extra information. But the advantage is that it allows your database to be quick when finding specific records based on those keyed columns. So the rule of thumb is that you have to keep your indexes to as little as possible. So don't go ahead and index, excuse me, don't index every single column in your table, right? Choose a minimum amount that will allow you to do what you want. Now we do this because during website operation, you find that you're doing more reading than writing to the database. So every time you load a page, you're actually reading from the database. So that's a lot of reading, as opposed to when you're editing records and adding new records. That's fewer than the read operation. So that's why we kind of optimize for the read. Otherwise your website will appear very slow. So we can say key like that. Now here you can, I'm just saying key and then I say first underscore name like that, and that should be enough. But there are certain times when you want to name your key something else than the column name itself, even though it's pointing to that column. So you can just say key some name, and then you do the column I want to key is first name, right? So you can do it like this as well, but let's leave it like that. And this is the final thing here. So don't put a comma at the end. So this does it. We have a primary key. We have a normal key here for first name. We could do the same thing for last name as well. So let's do that. Don't forget that comma over here, and we are good to go, right? Now you can also put default values, like for the age, you want a default value maybe of 1, something like that. So you can say default 1. Here you can also put default values that you can say something like this, because that's text, so you put it in quotes like that. So that could be a default value for this, or you can say default should be null like that, which is an empty. Now you can still use small letters like that, it doesn't matter. Now, if the default is no, you can just say no like that to tell it that this allows no values, which means empty values. If you don't want it to do that, you can say not no like that, so it doesn't allow no values. Okay, this is great. We have what we want. So now I can just copy this. Now keep in mind that these return carriage returns here will manifest in your command line tool. So maybe not such a good idea over here. After you are done with this, you can actually, this will work just fine. It will put those arrows, I guess, until it finds a semicolon. So let's see how that copies over. So if I go here and then I say paste like that, this is how you're going to see it. So it will have those arrow until down there, and then we can now press enter, and then it says query OK, rows affected, 0 rows affected, right? Now we can say show tables in here, right? Keep in mind that the database is already selected, so we are running these commands on this specific database. So if I press, now you see a kind of table. Tables in my DB, and it's users, right? Good. Let's see, if I say show tables, I've never tried this, I just want to see, as tables. Let's see what that does. Okay, so there's an error there. Okay, I thought something would work, but it doesn't. Okay, cool. So that's how you see your tables in here. You say tables in, and that's the one table we have. Now, what if we want to read from that table? We'll just run a query and say select star from users, like that, semicolon, press enter. Okay, so there is nothing inside the users table, and says it receives an empty set. So now let's actually add some records to our users table. Now to add records here is very simple. So here we're going to say, let's do this. We say create table. So I'm going to make this file available for download. Okay, so that's how you create a table. The hash here means this is a comment, so that should work. I think also if you use dash dash like that, that represents an SQL comment. Actually, if I click here, there should be a SQL language somewhere. Let me go down here. Now that I think about it, yes, there we go, SQL. Very good. Okay, cool. So if I put that, it's still a comment. That's great. Okay, good. Let's go down here. And now I can save this as an SQL file somewhere. So I'm going to make it available. I'll just save it on my desktop. I'll say mysql.sql. Great. Okay, cool. So read from table, or let's say add record. So to add a record to the database, we say insert, because of course we are inserting something. So insert into users. Okay, and then we do this and that, semicolon. So here what we are saying is insert into users. Here we provide the columns, and then here we provide the values like I had shown you earlier. So here we don't have to provide for the ID. We can just skip it and say first name and then last name and then age, like that. And then of course we can go ahead and do more. Now with this, since empty space means nothing, we can still do it like this. So values now. So what's the first name? We can say John, and then comma. What's the last name? Bana. And what's the age? 30. Now you see 30 isn't in quotes because it's a number. You can do that. Now if you want to insert more than one record, you can simply duplicate this one a few times, as many times as you need, and put commas over here, and then you can just change the data. So we say Mary and Mary Jane here. Let's see. Let's go with Oprah here. If that's how her name is spelled, I don't know. I don't know how old she is. Okay, let's just play around with these numbers, right? Okay, so there we go. And we say insert into users, first name, last name, age, values are these. As simple as that. So I'm going to copy this and let's paste it in our command line. And that's what we get. And now when I press enter, it says the query ran okay. 3 rows were affected. Record 3 duplicates. Oh, okay. So records 3, duplicates 0, warnings 0. So this just means everything went well here. No warnings, no duplicates. Good. Now we can check to see if there's data by using the select statement. So here we say read from database, right? So to read from there, we say select all from users, which is the name of the table, just like that, semicolon. From table. All right, so there we go. We read all from the table like that. So select all, which means all columns from the table. Now, if we want to read specific columns, you see, read specific columns, we can say select. Instead of saying that all, that star, we're going to say first name, comma, last name. Those are the ones that we are reading from users, like that. Okay, so that's how you read specific. So I'm going to copy that and let's go here, paste, enter, and there we go. So we have all the records read there with all the columns. That's good. And then we copy this. Let's try that with just specific columns. And there we go. So you see now we have just the first name, last name, the ID and age are not here. And that's how you can read very specific columns like that. Now, if you want a very specific record, you have to think about it and say, which column is unique here? And what do I want? How can I uniquely identify that particular row? So in this case, that's why we have this primary key ID, because we know it will always be unique on this side, right? And the same way on age, sometimes two people can have similar age. So if you read based on the age, you could get 3 or 4 records. So if you want very specific, you need just to use the primary key. Now you can have other unique keys over here, and that's fine, but ID, the primary key, usually is the one. So here we can read by specific ID, like so. So read specific record. So to read a specific record by ID, here we're going to say select all, again, from users, and you use the where clause. You say where, and then you name the column is equal to, and then you give the ID that you're targeting. In this case, ID is equal to 2. So I'll copy this and let's try that out, and we press, and you see I only get record number 2. Now you can combine these two, like with most MySQL operations. You can combine several of these to, like for example here, we are reading very specific columns, right? So read specific columns by specific ID, like that. So you can combine the two. Just get that from users and then say where ID is equal to 3, something like that, right? So let's copy this, copy, and let's paste. There we go. So we read a very specific record with only the columns that we need. Okay, so since we are here, so let's talk about what CRUD is. So I'm going to put here CRUD. So what CRUD stands for is create, read, update, and delete. So you have to know how to run these operations to say, okay, I can manipulate data in a database. So we know now how to create stuff. That's good. We know how to read stuff. That's good. We know how to update. Do we? No, we don't. So what remains is update and delete. So let's see how we can do those two. So to update a row, so here we're going to say update a row. Now you can update more than one row as long as that row meets the where clause. Whatever matches the where clause is going to get updated. So here to update, you say update, and then you name the table, update users, and then you say set. Now you give what columns should be what. So for example, I want to change the age here. So set age is equal to 100, so that it's obviously different. And then if you have more than one column to change, you can say age is equal to 100, you put a comma and say first name is equal to Peter, for example. Okay, and then now you tell it where to change this. Now you can actually just run this as it is. The problem is that it will change every record in the database, in the table. It will just say age is equal to this with every single record, and that's not good. So you have to be careful about that. You make sure you add a where clause whenever you're updating or deleting. So where ID is equal to, now you don't always have to use ID. You can say where age is equal to a specific age, right? And then it will update more than one record. But in this case, we want to update actually just one record. So we say where ID is equal to 3. Okay, so we are changing the Oprah Winfrey record here. So if I just copy that and come down here and paste. So update user set age is equal to 100. First name is Peter, where ID is equal to 3. So if I press enter, it says rows matched 1, changed 1. That's good. So now we can just select, say select all from users to see what we've done. And as you can see here, where ID is 3, the first name is now Peter, the age is now 100. Okay, that's good. But what if we want to delete this record here, right? So say delete a row, right? So to delete a row, we say delete from users, which is the table name, and then you tell it where to delete, because we're not specifying columns here. We're getting the entire row and throwing it away. So we just say where ID is equal to 3, that very last one. Okay, great. So delete from users where ID is equal to 3. So if you don't specify the where clause and say delete from users, it will delete every single record. So you have to be careful about that as well. Make sure you apply a where clause. And also, if you use the age, for example, because there are repeated values in the age, just keep in mind that it will be more than one record that's deleted. Now, if you want, you can use the limit. Okay, so we're going to see how that is done as well. So you can say limit, so I'll talk about that in a few. You can say limit 1 like this, which means it only delete one item at a time, right? Limit 1. Even though there may be several records with age 3, it will just get whatever it finds first, it will delete. Now, you may be wondering, how does it know which one to find first? Should it start from the beginning or from the edge to read? Now you can use the order clause. So we're going to get to that as well in a second. So you can say order by ID descending, for example, like that, and then it will delete the one that it finds, the very latest record that has age of 3, and so on. But for now, let's just do this. We'll say where ID is equal to 3, like so. Okay, so let's run this and see how that works. So if I paste and press enter, it says rows affected, 1 row affected. Great. So let's see now what we did. So select all from users, and there we go. So we don't have a third record. Now look what happens when I try to add one more record, right? So let's see here, we're going to say insert into users, and then let's say first name, last name, age, and then our values over here. Now you could also, using the insert, you can use set first name is equal to this, last name is equal to this, and it will actually work with the insert just like we do with the update. But for now, let's just do this. So I want to bring back Oprah Winfrey, comma, Winfrey, age, let's put that 60 we had put there, and press enter. So great. Select all from users now, and there we go. Now look at the IDs here. It doesn't say 3 over here, it says 4, and that's because it says 4, and that's because the 3 was already used. There's a counter, internal counter in the table that tells it where the auto increment currently is right now. So instead of 3, it adds a 4 there to avoid repetition. But if that's not what you wanted, let's delete this record again. So say delete from users where ID is equal to 4, right? Okay, so now let's select all from users. So that record is gone. But what we do if I want, because if I try to add one more record now, it's going to be ID is equal to 5. Now there are certain times when you want to change the auto increment for some reason, because reasons, right? So you could do that by saying alter table. By the way, this is how you change things in a table. You always start with alter, and then you say table. Oh, actually, we'll say alter users, right? And then we'll say, we won't say set, we just say auto. Do I leave a space here? I don't even know. Let's try auto increment, or maybe we use an underscore. I don't know. I haven't done this in a while. Auto increment is equal to 3. Okay, so let's set that to 3. So I have an error there. So let me see. Maybe let me leave a space. Does that work? No, it does not. So maybe that wasn't the problem. So let me put an underscore here. And I think I should have mentioned that this is an actual table. So alter table users, auto increment is equal to 3. And that actually works. Great. So let's save that. So let me just copy this. Let's save it in our text editor. So say change auto increment value. There we go. Pretty cool. So if we come back over here, now I can run that query that I run to actually create a record. So I can just go ahead and copy that, copy, and go down here and paste it. So paste, boom. Now let's do select all from users, and there we go. Good. So you see now it's at 3 again. Okay, so now we know CRUD and how to do it. Now let's get into a little bit more intermediate stuff, right? All right, so let's look at order, offset, and limit. Okay, that's how we can manipulate information when reading. Now keep in mind that whatever we use on order, we use on the select statement can also be used on the update and the delete, right? So keep that in mind. Wherever we're saying offset, limit, order, all those things can actually work for the update and delete. Okay, so let's say, for example, let's add a few more records, right? So that this is a bit more exciting. So I'm going to go here and let's go back to our very top where we insert some records here. So I'm going to copy this, but I just want to change the contents of this. So I'll just open up a new one. And here we don't have Peter yet. It's hard to think of names, you know. let's see here. James, or something like that. So let's just randomize these numbers as well. Let's say 20, 34, 50. Okay, so I just wanted some new records there. So we're gonna go in here, paste that, and run that. And then we can now do select all from users. And there we are. So at least we have 6 records now. Okay, cool. Now, if you've noticed the order of reading, it starts with the first and then the last record, but we can change this order into 2. There are 2 options. The default is ascending order. There's also descending order. So here I can do this. I can say select all from users, and then we say immediately order by. Now we say order by. Now we give it the column we want to use to order. So I can say order by ID descending, like that. So descending is the opposite of ascending. So if you want to use ascending, you do it like that, and then descending is like this. So let's do that and see what happens. So now, as you can see, we are starting from 6, 5, 4, 3, 2, 1, which is pretty cool. So let me save that as part of our record, right? Let's go down here to our records. Order, descending or ascending. So we can do this, we can do that, and we can do this. So you can choose between those. And also keep in mind that you are not limited to the column that you are using, right? So you can say select all from users, order by, and then you say order by age, for example, ascending, like that. Okay, so if we do this, then it will order our records using the age instead. So you see here, the numbers here are all jumbled up, but the age here is ordered properly. Okay, so that is great. So the order here is up to you. Now, if you don't specify the order, you just say order by. So let me just redo this query. But then I just say order by age, it will assume that you want ascending order. So if I press here, I'll get exactly the same as I got before. Now you could still use order by age descending like that. Oops, what did I do? Oh, I forgot the age, right? Order by age descending like that. Okay, cool. So it starts from the top and goes down. So that's how you order things like that. But what about if you want to make pages? Now you want to shift from, let's say, you want to show just 2 records per page, right? Page 1, page 2, page 3. So this is where the offset and limit comes in. So first of all, let's understand the limit. Now to limit here is limit records. Let's say limit results, right? So to limit the results, you say something like select all from users, and then you just say limit, let's say 2, for example. Okay, that will show you only 2 records. So let me copy that. Let's try this. Boom. And you see we have John and Mary. That's usually the first and second, right? But what if I want the ones in the middle? So that therein goes the rub. Now also, you can use the order by combined with the limit. So you just have to know which one to start with. So select all from users, and then you say order. So the order always comes first. So order by ID descending. Let's try with ascending first, and then say limit 2, like that. So this and this will return exactly the same results, because in here it will naturally order by ascending. But if we change that to descending, then we get the last two records, whereas here we got the first two records. So that's how you combine those two. So if I go here and paste that, you will notice that I got the very last two. Okay, now let's talk about offset and see how that plays a part. All right, so adding an offset is how you get records in the middle of the first or the last. So here we know how to get the first two records. Here we know how to get the last two, but what about some records in between? And this is where offset comes in. So offset is usually used for pagination, so for making pages. So let's say, for example, I want the first two records. Of course, I'm going to do this, and let's just explicitly tell it to order by a certain order. So we say order by ID ascending. So this and this are the same because by default it will order by ID ascending. But now, what if I want the next two records? Now, before we go to the next two records, it's good to know that offset can be set to 0, which makes it completely redundant in this case, but it's good for when you're adding pagination, because then you can just change this number and then keep moving forward. So here we're going to get the very first two records. So let me copy that and let's come back here. Let me go up a little bit like that, and let's paste that guy and press enter. So I do get the first two records as predicted, but if I paste that again, and this time I say offset 2 like that, I'm telling it to skip the first two and give me the next two, because there's a limit of 2, so it just says offset 2. Now keep in mind, you can use offset without limit. It just means it will skip a certain number and then bring the rest of the records down. But because we want to paginate, we're going to add a limit as well. So if I do this, I will get an equivalent of page 2. So you see here there's 1, 2, and here there's 3, 4. Now if I repeat this and say offset 4 this time, so it will skip the first 4, and there we go. So as you can see now, we get the first 1, 2, 3, 4, 5, 6. So these are pages. This is how we paginate. We say limit and then use an offset to skip the ones that you don't want to see first. Now, if you notice something, you will see that there's a limit here, right? There's a limit of 2 and offset 2. There's a limit of 2 and offset 4. So if you notice here, this number and this number are divisible without a remainder. So I can do this by say offset 3, for example, instead of 4. I can do that. But the problem is I will see a repeat of at least one of the records, because now it will go instead of 3, 4, instead of getting 5 and 6, it will get 4 and 5. So it's repeating Peter here again there. So you may want this kind of thing in your pagination, then you could do it like this. But instead of having to put these numbers directly, there's a formula that I use specifically for pagination that will give you what offset you need depending on the page you're on and the limit that you have. So formula is like this. Formula. This one is you get your page number. So this is how you get your offset, right? So the formula is like this. Offset, which is the value of offset, is going to be equal to the page number minus 1, and then you multiply that by the limit like this. Okay, so this is the formula for how to find your offset, given you know the page number and you know how many records you need to show per page. So let's see if this will tally very well with what we had done previously. So let's look at this. So it's page number minus 1 times the limit. So let's keep that in mind. So what you can do here is like this. So we are starting with page 1, right? where is page 1 here? So this is page 1, right? The offset is 0. So let's see if we can find 0. So since we're on page 1, we're going to say page minus 1, because that's the formula. Page minus 1, and that's 1 minus 1 is 0. And if you multiply that by the limit, which is 2, any number by 0 is 0. So you get an offset of 0 on page 1, which is correct. Okay, but on page 2, there's 2 minus 1, which gives us 1, and then 1 times the limit, which is 2, which will give us this offset over here. That's 2. Let's see if we, on page 3 we'll get 4 as the offset. So on page 3 we say 3 minus 2, that's 2. 2 times 2 is 4. So that's the 4th offset. So you can use this formula regardless what the limit is here. The limit could be, let's say I want 8 records per page, and for as long as I know what page I'm trying to access, I can create a query that queries that specific page. So this is how you use the order by and limit and so on. Now let's look at something, a different way to order things, right? Order ascending or descending, right? So over here, so we can order by more than one column. Okay, so here let's say we say order by ID descending, right? Now let's use something else that's let's get back here for a second. So I want to just do a select all from users, right? So this is what we have here. Now I'm ordering by ID, but I can also order by age, like I said, but I can order by 2 as well. So when for me to see how well this actually works is, let's give 2 different let's add one more record here. So I'm going to add one more record here that has similar age, for example. Is there any 2 that have a similar age? No. So what we're going to do is run an insert here. So I'm going to say insert into users. The values are first name. Now if the columns, that is, now if you're going to put all the values, you don't actually need to specify the columns as well. When you're doing this, you can just say insert into users and then go ahead and put values like so. So since I'll give every value here, I'm going to say 7, comma, and the name in this case will be, let's say, book James or something. Now I want this to have maybe 30, like that, which is already there as an age. So let me press enter for this. So we have a new record now. If I'm going to check here, I will see it. So let me copy that, let's paste, and there we go. So we have one more record here, quite all right. Now let's try and order these guys by age, right? So I'm going to say select all from users, order by age. Let's do ascending, right? So this is what we get. So here we start with 20, 24, but then there's 30 and 30, right? Now these are put together like this, but I actually have no control here over which one of these actually comes first. Okay, so they are put together like this, but John comes first simply because the ID is bigger. But what is smaller, I mean, it came first. But what if I want book to be put first here? Since if we look at alphabetical order here, book can come here first than this one. Whenever I find duplicates like this with the one what I'm ordering by, I can tell it to order a different way here as well. So we can do that by simply doing this, and then we say order by age ascending, and then we put a comma and say first name ascending as well, like that. Okay. And now, as you can see, when it finds this order like this, it will order. You see, book here comes first and John, which is right there like this. I could have achieved the same thing by ordering by ID descending instead, right? If I do this exact same thing, but instead I say, okay, when you find two that have the similar value on age that you're ordering by, just put ID and then put descending there like so. So in this case, I will get exactly the same result I got here, because when we say descending ID, we mean the bigger one first and then the second one. So this is how you can actually order by two or more columns. You can keep going and say if those two, then order by this. If there are duplicates in there, order by this. You can keep going and going. So this part here which says ascending like this, because by default ascending is the default. We don't need to specify any of this. So we can achieve the same result that we achieved here by simply putting the column names there. Because both of these are ascending, and ascending is the default ordering thingy, we can just remove those and we will get the same result. Order by age, let's see here, and first name. Yes, so it does ascending for the first name and ascending for the age. So that's how you can order by several columns there. Okay, so let me add this here, order by more than one column. Like that. Okay. So now what we're going to look at is the how to display information about your table and databases. So show database information. Now this will help us, for example, if in here, if you don't know what table you are dealing with, what kind of table you're dealing with, here I can read and say select all from users, but I have to know if there's actually a table called users in the database. Now we already saw how to do this previously by doing show databases like that. Okay, so just by saying show databases, you actually can display all the databases that are inside this installation. So if I do this, there we go, we can see all the tables that exist here. You can go through them and see one by one. Okay, but what about if I want to use a specific table? I've already shown this. You say use, and this is how we used this particular one. But then what if I want to see how the columns are in this table? You can say show columns in my show columns. Okay, so I know that there's this particular databases, but let's say I want to look at the tables that are in here. So we can say show tables in my DB. And there we go, we have one table there. So that's how you show tables there. So let's add that there. Like that. Okay, good. That's how you show information. But what if I want, now I've got the table, right? But what if I want to see the columns in there? There are two ways to do this. So if I want to see the columns in this table, I can say show columns, just like predictable, show columns in users, like that. And it's going to give me the column name, the field name, the type, whether it accepts no values or not, which is empty values. This one does not, these ones do. Now the reason, maybe I didn't explain properly, the reason why no can be acceptable, I'll explain it a bit later. Let me skip this for now. So the way we show tables like this, you could also just say describe users like that. It's the same thing. So as you can see here, describe users will give you exactly the same result as this one, where you see a description of the table. So let me just copy this guy here. Show columns, or you can say describe users, like that. Okay, so that's how you see database information if you wanted to. Okay, great. Now let's look at dealing with no values here. What are no values and how can you check for no values in here? So no, or null, means nothing. So no just means completely empty there. Now this is important because certain times, now let's say you want to sign up a user, right? And you have a table, for example. Let me come here for explanation. Let's say you have a table and we have name, age, and gender or something, and then we have maybe there's a balance, right? Or bank account balance or something. Or maybe there is address as well. Now, the user table can be quite long because you may want a lot of information from a particular user. But it's not a good idea to put all those fields on the sign-up page, because if the user sees a very long sign-up page, they may not want to actually sign up. On the actual sign-up, you can just ask them for their name, maybe their gender or date of birth or something. But things like the account balance or address can be added later once they sign up. Yeah, you see, you hook them and then you get them to give you more information like that. Now, if this requires a value in the database, then this record will fail to be saved because some values are missing. So what we do is we'll tell MySQL that we allow empty values in these columns so that we can allow saving even though there's no data in those particular columns. So that's how that's why we need no values sometimes. And as you can see here, when we describe, it even checks to see which of these columns can actually accept no values. But now what if you want to read columns only that contain empty values, right? How do you do it? So because no is a special value, you can't just use is equal to no or equal to, so let's see. Let's try accessing no values, or checking for no values is more appropriate. Yeah, because you can't really access emptiness, I guess. So we can say select all from users, right? Where? Now we want to check where there's an empty value. So where you say, instead of saying where, let's say first name is equal to no, like this. This doesn't actually check for no values. So what you say is no, like that. So let's check this out. I'm gonna copy this and paste here and press enter. So you see it returns an empty set because there's none of these that where first name is no. Now we can see that first name can accept no values. So let's try and add a record where first name is empty, or maybe we put last name as empty, right? So I'm going to say, insert into users, and since we are going to put everything there, so I'm going to do 8. And then the first name, we're going to put no. We don't put quotes around no because it's not a string, it's actually a type. So no, and then here we'll say Jones, something like that. And then age, maybe 56 or something similar. Let's press enter. Okay, so what does it say? Right, so I forgot the word values here. See, it's easy to forget these things. So values like so, and press enter. Okay, so now let's try and see what we have. So we say select all from users. Now there we go. We see on the first name here there's an empty value. I see no Jones. So let's try this this query again, where first name is null, and let's see how that works. So if I do this, it actually brings back that column. Now we can do the opposite and say where is not null, like that, and it just bring everything that doesn't have a null value like that. So let's try and do this and say where first name is equal to null. Let's see if that returns a result, and it doesn't, as you can see. So we can't use the equal sign. We have to say where is null or is not null. However, let's try and use quotation marks like this. Let me see. And even then, it doesn't bring back the result that is null. So we can try and say where first name is empty, like that. But in this case, it's equal to an actual value called null, and that doesn't allow accessing like this. So just remember, is null and is not null is how you get these empty values in case you need them. All right, so now let's look at aliases. But before that, let me save what we just done. Oh, checking for null is already there. Okay, that's good. Let me just duplicate this for a second. Is not null. Like that. Okay, so let's deal with aliases. Now, aliases is or are an alternative name, like a nickname to a particular column. Right now, aliases are very, very useful. We're going to see how these are very useful when we deal with joins and all that. But for now, let's have a brief introduction. So let's say, for example, you want to select first name, last name, right? But instead of naming it first name, because here you see it's got first name like that with an underscore. But what if I want to remove this underscore, for example, in my result set? So, or I just want to, yeah, let's just try that. So I'm going to say select all from users. So let me just select everything, right? But I want a very specific column, so I want to be very specific here. So I'm going to say first name like that, and then I will say as like that. This is how you create an alias. So instead of calling it first name like this, I can call it something else. I can say, for example, as name like that. Okay, so let's see what happens when we do this. Essentially, we are telling it rename first name to just name. Now, the alias only lasts for the duration of the query, so it doesn't really change the original column name. This is just a nickname for this particular query. So if I paste that here and press enter, you'll see that this is what I get. So there's a null name there, but the column name has changed to name like that. Okay. Now we can do a lot more than this. So let's say I wanted it to be named first name like that. So I can't just put a space there. I have to put this inside quotes so that it knows that this is one thing. So if I press enter, now you see the column name is actually first name like that without the underscore. So you could use this. This could be very useful if you're just loading the table as it is in the user's view without having to edit the column names like that. Okay, so that's one use for aliases. You can also rename table names as well. So I can say something like select all. Let's go back to selecting all here for a second. Oh, actually, I can't do this. So I can say select all from users as you, for example, right? Now, this won't look like it's anything special right now, because if I press, you'll just see nothing really has changed. But I've renamed temporal for a short period of time users to you. Now, why this would be useful is if you're running other queries over here, if the query is very complex and you keep referencing the users table, you can actually, instead of saying users, you can just say you in there. This can be extremely useful when you have table names that are quite long, and repeatedly typing them to reference the table can be a pain. So you can rename it to just one letter. So in this case, we won't see anything here, but we will see how this is useful when we're dealing with joins. I'm going to show you that. Now we can do much more with aliases. For example, I can say select or, right? So I've done already or here, but I can put a comma and then put something like first name like this from users, like that. So let's see what this does. So you see, I say select and then I put a star there and say first name from users, right? So it will select all the columns, but then it will also add first name again. So first name already exists, but it will add it there again because I've referenced it again. So you see we have first name here, last name, and then we have first name again. But this doesn't make much sense. Now I could rename this one with an alias. So I can redo this query, but this time I can say first name as name, like that. And now we have first name, last name, age, and name over here. But this isn't very useful. We'll see how this can be useful instead much later when we're using aggregate functions, for example, like sum, averages, and all that. Then you can tell it, for example, that you want to add the ID plus the age and then give an answer here. You could do that. You can do it like this. So here you can say ID. You just put a plus sign in there, like it's just normal math. And then you say ID plus age here. And then you put these guys in a bracket like so. And then you say as. Then here you can put something like total, since these are numbers, like that, from users, and press enter. And as you can see now, we have a total column here where we have 31. If you look at ID plus age, that actually tallies very well. So this is how useful aliases can be in situations like this. Now we can actually even do more than this. There are functions in MySQL, so I can just show you one function which is called concat. Now concat, we will talk about functions later, but we can use it simply here. I can say select, let's say first of all the ID, and then instead of me adding first name and last name, I can just say name and say as. Okay, actually this is not correct. What I can do is I can say concat like this. So I can say concatenate. Concat is short for concatenation, which means just join two things together. So say first name, comma, last name. Yeah, so we concat those two. Now I won't use an alias here. I'm just showing you how the concat here works. And then I'll do comma, age, and then from users, right? Oops. So there we go. Okay, a non-column last name. My bad. Last name needs to have a dash here. Okay, so there we go. So now we have a result here that shows us the combination of John and the first name and last name here. So this is all good, but we need a space between these names, right? So let's redo this. And second of all, look at the column name. This is ugly. Especially if you are mixing more than this, you'll find that the column name becomes unbelievably long. So this is where aliases shine. So I can do this. And instead here I can just say as name, like that. And then since I can concatenate two columns, I can actually concatenate actual text in between here. I can just do that and then a comma. Let me leave a space there. So what it will do is it will check if this is a real column, and then add it there. If something has quotation marks, it will assume that is actually just some text, and then so it will be first name space last name as name, like that. And then if we press enter, this is what we get. So that's what you expect, John Boehner, and we've changed it to name, like that. Now what if we try this very thing, but then we add some other text here, like comma, dash something else, like so. I've left a space here before something else. Let's try this, and this is what you get. You see, you can add or concatenate something in there quite easily, right? Or you can concatenate values from another table. Okay, so for example, you can say maybe the age. You can say John. Let me redo this. Let me come back here for a second. Here I can put a comma and say age, then a full colon like that, and then remove that, and then comma, and then say age, like this. Now, this can't be name anymore. This could be info or data or something like that. Okay, so there we go. Now we retrieve data that looks like this. So you have ID, info, age, something like that. Okay, pretty awesome. So just by using the concat function and an alias, we can achieve incredible results here and manipulate the data before we get it to our application. Okay, so moving on. All right, now we're going to be adding a few more columns to our table as we go. So it's only right that we learn how to edit a table. So here our table has specific information. So if we say select all from users, we will see all the columns that exist at the moment. But what if I want to add a user row, for example? Okay, let's say I want to know which one of these is an admin, a normal user, and such. I can add an extra column. Now, you could add this when you're creating the table, but what if the table is already created and you just want to modify it? This is where the alter table comes in. So this one is used to edit columns in a table. Okay, so we say alter table, and then you can add what you want to do. Now, let's say I want to add a column. I'll just say add at the end, alter table, and then add to add something. So here I want to add row. Then I have to specify what type. So this will be a variable character because I want to be putting the name of the row that's there. So I'll set it to 20 characters, for example. Now you can use int, you can use date time. There are other types that I didn't show just yet, which we will get to. So for example, you may want to add a date and stuff like this. Okay, so we can say add row variable character. So if I press enter, okay. Oh, so I didn't specify the table name. Sorry, my bad here. So alter table users, which is a silly thing to do, right? So that's the users table, and then I add something there. So if I press enter, oh wait, I have an error. So it's good to read these. Syntax near 20. So here it had said near add because there was something missing before this. So here it says near 20. So which means probably something is missing here. Add row. Maybe row is a keyword these days. So maybe we'll call it because sometimes you have to be careful. You may want to add a keyword as, like for example, you can't name a column select because select is like a keyword, something we use in the language itself. So let me try and edit that to user row. So there will be times when you have issues like this, but I guess that's not where. Okay, so that wasn't the issue either. So the issue here is this one here. I think there's an R missing there. So we'll keep it as user row, but then it should be variable character like that, varchar, like so. Okay, so that's done there. So if I now try to select, why do I keep typing that? Select all from users, and now we have user row, which is no. We could have added a default value here instead, right? User row, a default value, so that whichever new user comes in, they are by default a specific user. Having nulls like this is not good. So what I'm going to do now is delete that column. So that way we can see how to do that as well. So you can say alter table, and then you name the table, and then you say drop. Now you just say drop and then the name of the column. In this instance, you say drop column and then you name the column. So drop column user row, like that. Okay, so 0 records affected, but let's see if we select, we see that that column is now gone. Right? So that's how we alter things there. Let me be saving these things. I will save a couple of examples in the end. So now let's do that again. Let's do the alter table and let's add user row varchar like that. But this time let's give it a default value. So of course we can just say default like that and then put some text. So we just want whichever new person that comes in to be considered a user. So let me press enter, and then if I now select, you see that everybody is a user by default. Now we want John as number 1 to be admin. So here we're just going to update like we've done before. Have I even talked about the update yet? See, I've talked about so much, I even forget. Okay, so we did update a row. So that's great. So let me come here and say update users. And then we say set user row in here is equal to admin, but then we have to tell it where this should occur. Otherwise, it will edit every single record. So where ID is equal to 1. Now, also, I forgot to mention that you don't just use equal sign, you can use even the greater sign like this. You can say greater or equal to, like so, 1, right? Then it will replace everything. Or you can say if it's greater than 10 or less than 10, you can edit records based on that. You can also put and or and stuff like that. You can say where ID is equal to 10 and, or you can use the or. So we're going to see how to do that next. But for now, we're going to say add ID is equal to 1 like so. So if I press enter, I forgot the word where. So now looking at this, you see set then ID is equal to 1. So it would tell me that the problem is somewhere here. And as you can see, it says syntax to use near. So whenever you see this use near, you look at, oh, ID is equal to 1. So the problem is most likely here. So we'll put a where text there. Now, keep in mind that spaces are nothing. You can put many spaces like this and it will still work just fine. It's a valid query. So if I go back now to see the select, you will see now that one of them is an admin. Okay, cool. But now let's do, where is this here? Let's add one more column. Now you can also modify a column, right? So if we say alter table users, let's say for some reason I don't want this to be varchar anymore. I want it to be a type of text or type of int, for example. I want to convert the whole column to only accept integers. So I can say alter table users, and then let's go here for a second. Let's add one more column. Alter table users, and then we're going to say add, we'll just call it test, right? This one test is going to be equal to varchar of 10, like so, but then let's accept no values like that. Okay, so if I go to the select, you'll see that there it is. But what if I want to change test to only allow integers, right, instead of nulls? So here I can say alter table. Now, I don't know, you could lose information by altering a table because, for example, if the data in there was user like this text, and then you change it to an integer, of course, user cannot be an integer, so it will be changed to a 0 or something like that, so you will lose that data. So you have to be careful when altering table types or data types. So you can say alter table users, and then you say modify column. Okay, so we modify the column called test, and then we change its type to int instead, something like that, and then we say the default value is 0. But for now, let's not even put a default value. So if we do a check, so test now, if we say describe users, you will see that test now is int. It's not a varchar like we had done before, okay? But let me alter it and say default. Let's do this. And then let's put a default value of 0 like that. Let's try that. And then let's select all from users. Okay, so that didn't change because it's actually allowed to host no values. So let's alter this again, right? So let's modify test to an int, but then we add a default value of 0, and then we say not no, like that. So it doesn't allow no values, right? Okay, so there were some warnings there, right? Because the data is wrong. So let's do this, but there it is. So now all that data has been changed to a 0. I think the warnings were that data has been altered in the table by changing these things. Okay, so these are the things you can do to modify this, to change the column type. Now if I say describe, right, describe users, I will see that test is an int and does not allow no values anymore because we said not no on the other thing, and there is the default value. Okay, cool. So now we want to look at aggregate functions. So there are functions that we can use to get specific results. So in this case, let me first delete the test column here for a second. And before I go further, I may forget, we need to know how to alter a table. So let me copy these queries here. So we have aliases there, right? But then we also have, alter table, just so we know where we've been. So here we can say add, let's start with adding, add test, int default 0, not no. Then modify column test, and we change it maybe to a varchar. Right, and say 10, not no, and then we can eventually drop it. Drop column test. We don't need to specify any of that. Okay, so that's how you add, let's see here, add, edit, delete columns. Okay, great. So that's how we do all of that. Now let's look at aggregate functions. Now aggregate just means to put together, like if something that was combined from several things. So that's an aggregate. So here the functions we want to deal with are first count. These are functions because they've got brackets around them. There's count, there's sum, there's min, there's max. So count, sum, min, max, there's average, and a few others. So they pretty much work in the same way, so you can find out what these are. So for example, let's say I want to count how many records are in a table. So I can do select all from users, for example, right? But if I put count around this, like so, now you can put one single column in here, like so, maybe count ID. It seems intuitive that if it's counting just one column, it will finish early. But no, just put the star there for all columns because it's optimized to run better like this. Okay, so select count from users. This will give me the total number of records in the users table. So let me come back here. Let's scroll down a little bit. This thing is getting long here, so let me exit and then clear the screen. Okay, then let me log in again. MySQL root, sorry, like this. Okay, so we are back in line. I need to use a specific database, so I'll say MyDB, and there we go. So things are back to normal. So now select count from users like this. So this is what you get. There are 8 records in users table. But look at the column name. It's called count star like that. This is not good at all. So what we've learned from aliases, we can use here as well. So I can do this. I could say select, and then you just say as total, or you can name it whatever you want, or you can just say stuff like that. And now you see the column name is stuff, which is better than this. So you can name it to anything you want. Now, in the same way, you can use aggregate functions to some other aggregate functions here. Let's see. Let me grab this one. Let's put it here. Okay, select count is already there. You can say Sam in the same exact way. So let me copy this. Let's come here. Wow, this gets filled up really quickly, right? So if we do that, oh, okay. Now it can't sum up all the columns, so that's a fallacy right there. So what I'm supposed to do is look for a column that is numeric and then try to sum it. So for example, the age. So if I do this, I actually get a total. Let's do a select all from users like that. So you see that there is a total here. So if you add all these numbers, that's what you get here is the sum. But let's look for the minimum now. We can do exactly the same thing with min instead. So let me come here. Let me duplicate this. This goes for min and max. It's exactly the same thing. But of course here, let's change that to age because it's the only numeric thing. So what did the error say anyway? Syntax error near, okay, I see. What if we try to count a different or sum? We can say sum. Let's try first name. What happens then? So it will give us 0 because it doesn't give an error, but it gives us 0 because there's no summing text there. But if there were numbers somewhere, it would actually add those numbers and give you a result. So let's see first of all if we can alter test to become varchar or something. Wait a minute. Okay, so let's go to first name and change record number 8 for first name to be a number. Let's try that. So I'm going to say update users set first name is equal to, let's put a number here like 10, okay, where ID is equal to 8. Okay, so one match, one changed. So let's see that in action. And there it is. So now first name is 10, right? So let's do a sum now. We can say select sum first name. Okay, first name and column like that from users. So you see there's a 10 there. So it will find every value that is numeric and add it there and ignore everything else that is text. So that's important to keep in mind. So the same thing you can do for min and max and all that. These are all aggregate functions. So let's try min. So min will give us the minimum amount. So let's do that. And the minimum is 20. So if you look here, you will see that 20 is the lowest. We can do exactly the same thing for the max and find the maximum. So let's go to max age. And the average does exactly the same thing. So let's go back here. Oh, that's max, right? So max is 60. AVG. Now average is found by adding everything and dividing it by its own number, you see. So that means, what it means is this, by the number of items, right? What it means is this: if I do a select all from, I'm pressing the up arrow key, by the way, to cycle through the commands that I've already done, in case you're wondering. Okay, so average is you add everything together and then divide by the number of items that you've added together. That's how you find the average. So if you do that, you find that number. Okay, so all of this is nice and dandy. Our aggregate functions work just fine. Now, you should always remember that with all this, you can add where clauses here as well. So you can say something like select count from users, and then you use a where clause at the end here, right? Where clause is addable here too. You can say where the age is equal to 20, for example. So it only count records where the age is equal to 20, or you can say how many of these people are above 20. So you can say where age is greater than 20. So let's copy this here. And also remember, everything we've learned so far, you can actually combine this. You can put an alias as well and say as total, something like this. So let me copy this just to show what you can do with this. And let me put this back to its basic form. Let's do that. Okay. So this is very valid. You say total, users, where, etc., etc. Let's do this. Boom. And then you say 20. So anything greater than 20 here, there are only 7. So there's only one that is less than 20. Yeah, 20 itself, actually. So if I lower this number and say, or I increase this number, how many people have age greater than 40? Okay, now if you want 40 and above, you can say greater or equal to. And there are only 3 like that. This is how you can find it. You can add the where clause, combine those two together to make something. You can also say where, because in the where clause, like age is equal to 20, you can even put the or and say age is equal to 40, like that. There's only one. So it will look for where the age is equal to 20 or age is equal to 40. You can even use the and here. So you can say something like, so there's or, there's and, what else is there? It's just or and, right? And not. So here you can say where age is greater than 40 or age is less than 10. All these are valid. Now, instead, you see these two double pipes, that's one way to do it, right? Or instead of the double pipes, you can use the or itself, like or, like that, as in text. So there's or, there's also and, which means only when all of both of these are correct does that actually match. Or just means this or that. This here just means this and this. So you don't have, you can, it's not just that you can put 2, you can actually put many of these. You can say and this, and then you can even reference other columns. You can say and first name is equal to John, and you can keep going. You know, you can go to infinity just adding and conditions until all of those are met. Will it work? Also, you can combine with and or to get what you want. Let's say, for example, where age is greater than 40, and then you say or, and then you put brackets like that and say or age is less than 10, or in here you can even put an and age and first name is equal to John. So this is very valid. If you put brackets like this, it means it will start by evaluating this inside the bracket, and then the answer to that, it will OR it with this. So putting brackets is important because then you control the order. If you don't put these brackets here, there are rules that the system will follow. It will either start with a greater than, to either start with an or an and you can't really remember this order all the time. So it's better to put brackets like this. So everything inside brackets, because as you know, BODMAS, right? Bracket is always first. So anything in brackets will be evaluated first before everything else. So you can put things inside brackets, within brackets, and so on, and it will start with the innermost bracket and work its way outward. So that's just some things to remember here. So you can use OR, and if you don't want to use this kind of AND here, you can use the double AND like that. Those two like that, that represents this AND exactly the same. It's the same thing. So in this case, I can query something like how many items, or let's just say select all from users where age is greater than 10 and what else? Test is equal to 0. Okay, so test is 0, age is greater than 10. If you look at this, they meet all those conditions. So you can combine these to infinity. All right, guys. Okay, so moving on, we want to start, let's do one more thing, then we can start dealing with combining tables. Now let's look at grouping results. So there's a keyword called group by. So if you have results that you want to group, let's say for example here we're checking how many items, how many records are inside users. Now what if we don't want every single record to count? We want to group by the age, for example. We want to know just the uniqueness of the ages. So we can write something like select count from users, or let's just do select all from users, and then say group by age, like that. So you can group by any column. So what the column we would do, let's look here. Any duplicates will be grouped together. So we're grouping by age, which means there are two 30s right here, 30 and 30. And then it means it only show one of these. This one or this one. So if I do this, group by age, all right? So you will see that some of the records are missing here. The order is jumbled up. So what we're going to do is we're going to say group by age and then say order by. So the order by comes after group by, ID ascending. Okay, so we have grouped by age. And so if we look at the old record, we will see that 30, there's only one 30 here. Usually there's this one, and this one. So book and John cannot both exist at this point. So there's John, there is no book here. All right. So order by, okay. So that is good. That's how you group items. Now you can group by even user rows, for example. You see all these have the same value, so we can just show two of these. So we'll see how this is more useful when we're dealing with, usually this is done mostly with aggregate functions. So let's go here and say group by user row instead. Okay, so we get only two results here, and you can see admin and user, just the first two. Now you can combine this with the aggregate like count. For example, you say select count star from users, then you say group by user row, Now it doesn't matter the order because we're just counting these things. So I'm just going to do that. And there it is. So we group by user row, right? And then it tells you the number of each group. So you see here, there's 1 and there's 7. So it just means there's 1 admin and then there's 7 users. Now you can't know by just looking at this. So what we can do is let's show more records here, more columns rather. So let's go down here again. I'm going to do this. So we say select count and then we say as number like that, right? So that one will be called number. And then we can do user row here like that. So if I press enter, at least now it makes sense. You see there's 1 admin and there are 7 users. So this is very useful like this, because then it can tell you how many items are there by type. And this is number. At least we use an alias there. So it shows you how you can combine all the previous knowledge into one of these. You can even put a where clause here. You can say where user row from users, and then you can put a where clause here. So maybe I just want where, let me redo this. From users, right? I say from users, and then you can put a where clause. You can say where row or user row, or where ID is greater than 5, something like this. So if we start from number 5, there's no admin because admin is an ID number 1, so we just get one group of people. So you can put where clauses here, combine them with and, or, and so on, and you can search by specific columns even here. Okay, so let's say there were several types of user rows. Let's say let's add that, right? Let me just do select all from users for now. Like that. Okay, so we have this, right? And we have only 2 types of rows, but I want to add maybe accountants. Let's say number 7 and 8. So here I can do an update, right? I can say update users, and I'm going to say set user row is equal to, here we'll say accountant, and then we'll put where ID is greater than 6. So those last 2, right? Now if I do select all from users again, you will see that now there's accountant here on user rows. So not just that. So now if we try and do select that aggregate thing we did, this one, this query right here, which has an aggregate and a group by here. If we do that, now we have 3. You see there are 2 accountants, there's 1 admin, there's 5 users. So you can group things like this in terms of results. Now, what if I want to just get to count how many there are within admin and user? I don't want to include accountant, right? I just want admin and user. So I can do this by putting a where clause. So we'll do exactly the same query. The only difference now is we are grouping by, but we are putting also a where clause here. So we say where user row. Now here we can say user row is equal to, and then we can put some user rows in here. So where it's equal to admin, but then you can also say or. Now you have to repeat the word user row here. So you say user row is equal to user, right? Something like this. So so the text is wrapping around on the other side as well. So maybe you want to see this query from the text editor. Something like this. This doesn't have text wrapping, does it? So let's go wrap text. Okay. It's word wrap. Yes, yes. Okay, so select count as number. So we rename that to number. We also show user row from users where the user row is equal to admin or user row is equal to user. group by user row. So in this case, it only consider 2 of those. Now, this is all well and good, but what if you have like 10 or 20 of these? It will become tiring very soon to keep saying where user row is equal to admin, or user row is equal to what, or this. So what you could do instead is you could use the in. So instead of using equals, you say where user row in. So you say in, and then you put a bracket and just list the items that you want included. So here I can say user like that. So this is way shorter than what we had. So we say where user row in those. See? So yep. So this should work just as well. So let me copy that. Now this in comes in very handy when we start combining tables as well. So let me paste that and press enter. So now you see it only includes what we asked it to include without the accountant. So admin and user in there like so. Okay, so that's one way of searching for stuff that is in a, maybe you want to search for an array of things. So that's how you create that array and say in instead of equal to, right? Now, speaking of which, we are going to try and do a search here, which has a similar search using like, okay. So let's say you want to search for a name in the, database. Let me read everything from the database again. Okay, so there we go. Now, let's say I want to search for somebody in the database and I don't know really their first name and last name. I don't know the complete name. For example, I know there's a first name. Maybe it starts with J. I just know that. So how do I fix that? So what you can do is you can say select all from users. And then you put the where clause, right? So we are searching in the first name column. Now, in this case, we will say where first name. Now, instead of saying equal to, we are going to use the like keyword. Okay? So like, and then in quotation marks, we say, let's say maybe I just want P and R. Okay? There's Opera that has this, but let's see if it's going to find it. PR like that. Press enter. Empty set. It doesn't bring anything. Now the reason is there is nothing like that in here. But what we can do is we can put what are called wildcards to tell it that, like a %sign here and a % at the end here. So what this does is that it says we don't really care what's before this text and what's after this text. For as long as there is PR somewhere, you can consider that a match. So if I press enter now, you will see we find Opera here. That's how you search for people in the database. Now it's using the first name. You can do this and say where first name like that, and then you can say or. I like using the double pipes like that, but you can say or last name like. Usually you're searching for the same value, right? In the text box where you type in the search term, usually the search term is the same. So here we'll do exactly the same thing. Press enter. We'll get the same result. You know, it will check for the first name, or if the last name has a similar name. That's just a way to make sure that if you don't know which one of the two they are searching for, you can grab both like that. Now this is not the % is not the only wildcard you can use. You can also use the underscore. So what I would do is, let me select that just so we can copy it to our thingy here. All right. Now you can also use the underscore. So let's look at this. You can say select all from users where first name. So for now, I'm just going to use first name because we know that we can use or and repeat the same thing. First name like. Now, in this case, we know that Opera starts with O, right? So we can just say anything that starts with O by putting an underscore, and then we say prop like that. Okay. So this is very valid. It just means we don't care what the first character is. As long as it has that at the end, it should be valid. So let me copy this and let's see if we can find that result. And Opera comes in. So if we look at, for example, other examples here of names, like for example, book, right? If we can also say something like this, right? Instead of this, we can just say, I want something that starts with B. I don't really care what's in the middle, and it ends with K. Something like this. This is very valid. You see it gives us book like that, right? You can also say something like it can start with book, and then I don't care what, at least 2 characters in between, and then K. You get book again. So this can be useful for searching maybe something like Jane, Jade. Those are similar. You can swap out the N instead of Jane. Do we have Jane in the list here of names? No, we do not. Okay, so if they are both similar, let's try and add 2 records that are quite similar here. Yeah, but I guess you get, we might waste time doing that, but you get the idea. So you can do this. You can also do, let me put it like this. Instead of that, you can say boo, and then you don't care what's at the end. This could be book, this could be boom, this could be boof, whatever it is, whatever words you know that are like that. So that's for a placeholder. And you can do more complex things. Like for example, you can say you don't care what characters are here, but then here it should be a K, and then here you can have any character, and then you can put some other characters here and put, so you can combine it to make exactly the pattern that you actually want to deal with. So just make sure you don't put equal sign, but you use the like keywords. Okay. Now you can also use regular expressions to search for. So if you're good with regular expressions, this could be very good for you. So let's try first of all and get everything here. So I'm going to say select all from users. Okay. So to use regular expressions, you can use the R like. So you say select all from users where first name. Now instead of just typing like, you put this small r at the beginning. R like, that means you've turned this into a regular expression. Now let's look at, if we say John here, we can say, let me see, I've actually never used this before. Plus, will this work at all? Oh yeah, there it does. It does work. So it brings us everything here. So if you know regular expressions, I think I have a playlist for regular expressions, though I didn't finish it because it didn't get much traction, so I just gave up. But I think I went far enough so you can learn the basics of regular expressions. So what this means is that A to Z, it means you want a character from A to Z, which is small letters. That's what you're searching for. And that's why you put it in a bracket like this. It means this is a series or a range from A to Z. And then the plus just means as long as there's one or more characters A to Z, that's good enough. So if you notice, it didn't bring the number 10 because this is a number. It's not actually text. So we're not accepting that in here. You could accept numbers by going in there and saying 0 to 9 because those are numbers. And if I press enter, it will bring all the records now. So regular expressions are pretty interesting. So you can run regex right in here, which is very, very cool. Regex are more advanced pattern making because you can do, let me see what we can do here. Let's try, because it looks like it's case insensitive. So I can say something like, if it starts with O, like that, and then that should be enough actually. O, and then one or more characters at the end. Let's try that. Okay, so anything that starts with, that has O, actually that's what it does. For as long as there is O and in one or more characters of O, that's good enough. Because if I didn't put one or more, I just went with O like this, it will find anything with O inside it. So, but if I say it has to have O at the beginning, I'll put a caret here, like that, okay? So it only show me opera. But what about something that has an O at the end? I can put something like a $sign at the end. So there's nothing that's like that. Or I can put a $sign of K to get something, whatever has K at the end, there's book. So you can do so much with regular expressions there. There's a website for regular expressions, right? Which is called, what is it called? Regex 101? Let me try and find it. Yeah, there it is, Regex 101. Haven't used this in a while, but this is a thing where you can put some text here, and then you can try some regular expressions here, and then it will explain what the regex means and what you are searching for here. For example, if I type sum like this, you see it searches for the text that I have put in here, and so on. So those are just tips on what you can do with that. Okay, so let me just do this. Let me duplicate this for a second to show that you can use R like this, and then here you can put regular expression A to Z like that with a plus sign. Okay, pretty cool. So that's how you search for things here. What am I doing here? Okay, cool. That's how you search for things. So with this in mind, let's move on to double tables now so we can do more advanced things. All right, so now let's talk about combining results from two tables. We're going to start with the union keyword. So if you want to combine two tables, you can use several ways. There are many ways to do this. Joins, unions, that's what we're going to learn here. So combine tables using union. Okay, so we need to create another table here. We need to create another table here. So there's this thing here. We can copy that. Let me go down here to create another one. So on this, let's just say create new table, right? Okay. So this one we're going to call customers, right? That one was users. This one is customers. So it's like there are users in your table, and each user has a certain number of customers attached to them. So so we need to find a way to attach the customers to the users. But for now, let's not worry about that. Let's just do first name, ID, first name, last name, and age. Okay. Now on this side, we could add more things like the company that they belong to, right? Like so. Company, right? The company name here could be 30 or 50, and it could be empty as the default. So pretty much the same, except for one column that is extra in these customers, right? So we have a primary key there, and we can add more keys. Like for example, for the company, we want the company also to be searchable. Now you can search, keep that in mind, you can search without adding an index to a column, but it just makes things easier, faster when there's a key there. Okay, so we'll put a key like so. Now you may be asking yourself, if customers and users are combined together, like for example, let's say a certain user can have a certain customer, right? Why don't we simply put our customers right here? Because I could put just a column over here that just says customer or customers right here. Now the problem is, if we do that, it means one user can only have one customer, because we can only put details of one customer. The name, we can have the first name, last name, and so on for the customer, and we can't name them first name as well. We'd have to name them something like customer first name, customer last name, customer age, because if we just say first name, there's already a column named that in here. So these are the problems we would have if we put them in one table. So not only can we only assign one user to one, let me put it like this. Let me explain to you a little bit more here. So let's say we have first name, we have last name. Okay, so there's John here, and his last name. I should have done this in Excel. This is lame. Okay, how do I zoom this thing? View, oh, there's a zoom to selection. Okay, oh great, look at that. Went too far, but wait, how do you zoom out now? Oh boy. Ah, there we go. Fit. 50%. Ooh, looky there. Ah, okay, zoom to 100%. Let's try custom, 150. Ah, much better. So let's say I have John over here with his surname, and maybe there's gender ID here. Let's forget about this for now. So if I want to put a customer for this one, I would have to say customer first name. So what I'm teaching you here is modeling of databases. So let's move this here. How you design your schema for your table. Then there's customer last name, right? And then you can have other customer details. So here I can say customer 1, right? Oh, not that. Customer 1. Let's just put another name. Okay, so now we can see that John Peary here has a customer named Mary Jane. Okay, this is good combination here. But what if John has a new customer? What happens now? This becomes a problem, because now we have to repeat data, and this is where it becomes an issue. So because if I write, maybe now his customer is George Tembo or something like that. I don't know why I'm not capitalizing the other stuff, but this is the thing. John Peary here has these two customers, right? But these are empty rows here, which is a waste of space. And how will the system know that this belongs to that? Okay, that becomes difficult to know who these are connected to, because they are not in the same row. So the only way to do that is to repeat this data over here like that. So now we have John Peary repeated because it has to match here, and George Tembo here has to match with John Peary still. So this is much better now, because at least we can see that this guy is matching with both of these. Now this is just 2 records, right? Let's imagine this guy has 100 customers. So we're going to have to repeat his name over and over again, plus the 100 different customers over here. You may say, okay, these are computers, they're quite fast, so this is not a big deal, right? That's not where the problem comes in. The problem comes in, let's say we want to change John's name to something else. We say, okay, John's surname has changed or something, or we typed it wrongly, now we want to change it. It means now there are 100 records we need to edit just to change John's name. And that is a problem, because if something goes wrong within those 100 records and one of them remains with the old record, right, then we have inconsistency. Now we have what is known as dirty data. So now we have data that is not very useful. It has errors in it. And the longer this goes on, the more inconsistencies start building up in your database, and then you have a very bad database at the end of the day. Okay, so the rule of thumb is that anytime you are repeating data in your database, just know that you have designed your database table wrongly. You have to rethink it. You don't need to repeat data. There are times when you can repeat data, small amounts of data, yes, but whenever you find yourself having to edit more than one record when changing a record, that is a problem. Also, when the data is repeated over and over, that is a problem. Numbers can be repeated. That's fine, usually, to repeat numbers, but not text. If you find yourself repeating text or having to edit several tables just to edit one record, then you have an issue. So there are exceptions, of course, but in this case, for example, this is bad because we'd have to repeat this several times. So the way to do this is to separate this into different tables. So this has to go to a very different table altogether called the customers table. And then, so we move this here. Let me move this over here like so. So now, just to show that these are separate tables, right? So those are separate tables. Now, since this is a whole different table, it's a customers table, and this is a users table, how then do we know which customers belong to which user here? So what will happen here is that in here we have an ID column, right? And this one is 1 and this one is 2. Put it in the wrong place. So all we need on the other side is to have, this one will have a user underscore ID over here. Wrong place again. Oops. Come on, I'm trying to move this thing. Oh, my mouse is a feisty. There we go. So user ID. So now we can match these to that. So since these customers belong to John, and John, okay, so let's try this one is Peter. Okay. Something. So since these customers belong to John, it means here we put 1 and 1 there, like that. So similar values here, although repeated, but at least they're just pointing to John's record like that. This is better because these numbers will never change. This number will never change here, so this is okay. But we may want to edit John's record. So here if I edit John, it doesn't matter because they're already still linked by the ID itself. So the text may change, but the record remains the same with the same ID. So I can always retrieve and say, okay, whose customers are these? I'll always be able to retrieve John. Even if I edit the text in there, I'll still be able to retrieve this record because it's contained within the IDs here. This is what are known as foreign keys. This one is a primary key here for this table. There could be a primary key for this table as well. But then there's this foreign key here. This is a foreign key because this one is what links it to another table. Now you can actually specify in MySQL that this is a foreign key. That way it will refuse if I try to add a record here that has user ID that does not belong to this table. Let's say I want to add a record here with user ID 20. Since it's not in here, the MySQL database will refuse to add that record because then this is an invalid user ID. You can do those things, but personally I don't use foreign keys. Maybe I will start at some point, but I just think they add unnecessary complexity to. But don't take my my advice on this one. Foreign keys are better to use. Okay, so that's how we're going to do it. So let's do customers here for a second. Let's create that actual table. So we're just going to have to copy this. Sorry, I went off on a tangent there for a bit, but this is how we do it. Boom. So now at this point, if we say show tables, you see that there are two tables. And now we can say select all from customers, right? And there's nothing in customers, right? There are no records there. So let's add some records in there as well. So I'm just going to copy where we're adding records here, and we'll copy this guy. Let's come down here before we start combining stuff. So this one goes into customers, of course. Here we have age, but we also need the company name. So maybe this one is McDonald's. This one is KFC. Kentucky Fried Chicken. And this one could be Home Depot or something. Let's change the names here. I ran out of names, you know. Pete. Let's see. And yeah, whatever. So let me save these guys and let me run this and set into customers. Oh no, something wrong. Okay, there are more columns, right? It says column count doesn't match the value count. Okay, so that's very fair. That's because I forgot here that we need company. Okay, good. There's more data than the number of columns, so that's why it is complaining. Okay, fine. Now let's do a select. Oh, I don't have it in the backlist here. So let's do select all from customers. Let me Why am I in such a hurry? Okay, there we go. So we have customers here, right? And yep, now we need to match them to the users. So we have a primary key here, but let's add a user ID over here. So we're going to do alter table customers, and then we'll say add, and we're adding a column here called user ID. And this one is of type int. It should be the type, same type as the primary key we are matching on the other table. So add user ID as an integer. You can say it's unsigned if you want, and you can also add a default value of 0. It doesn't have to be auto increment, but you can put a key there if you want. So let's save. Boom. And there we go. So now if I do select all from customers, we have user ID over here. So let's match the user IDs on the other side. So I'm just going to give 2 people here. I'll say ID 1 on this one and this one, and then ID 2 here. So we're going to say update customers, set user ID is equal to 1 where ID in. So here we're going to use the in. So I'm going to do 1,3 like that. Okay. So update customers. This is how you see how you can combine all that knowledge to create unique queries. So if I do that, 2 matches, right? Let's check what has happened. And as you can see now, that one was, these 2 were given that. And then let's do another update here. So instead of in that, let's just put 2. You can still use the in with one value, but it's more efficient to just say is equal to 2. Okay, then now if we do select from customers, I gave it a value of 1. Sorry about that. Let's redo this. Let's set value is equal to 2 where ID is equal to 2. All right, there we go. So these user IDs are matching what's in the thing there. Let me do select all from users so we can make a comparison. So you see here they are customers and these are users, and we are matching. So this, what it means is this customer belongs to this user, the admin, and also this customer belongs to this user admin here because the ID is 1. But Mr. Dong here belongs to Mary as a customer here because Mary is ID 2, which is there as well. So this is how you can match 2 tables. Now, how do you read information using the union key, like we had said here? The union keyword, sorry. So union means you combine the result of 2 tables in the same columns. So the issue here is that the column number should be exactly the same. So here the column number is 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So which means we can easily just use the union keyword. So I'm going to do, it's used to combine 2 select statements. So I can say select all from users and then say union select all from customers. And this is the result we get. Look at this. From here to there, you see that these are users. And from here to there, these are customers. So this works for as long as the number of columns is the same in both tables. Now, if you have a table with different number of users, columns, sorry, don't worry. You can just, instead of saying select all, you can just choose specific columns. You can say ID, comma, first name, like this, for example, from users. And then same thing here, you just say, I just want the ID and the first name. Now, keep in mind that these columns don't need to be named exactly the same. So if I press enter, this is the result you get. Now, this result is from both tables. The order is weird here. I don't know why it ordered them top down, and then it just seems to have forgotten. Yeah, the order is all over the place. But you can order them nicer. Let's see, you can say order by ID descending. Okay, so as you can see, just that one order by works for both. Okay, so this is the combination of both tables. So regardless what original number of columns are in each table, it doesn't matter because we've just selected a few and that actually works. But like this, it's hard to know who is a customer and who is a user, right? By the way, let me change this to ascending. Okay, there we go. So now what I want to know is which one of these is a customer and which one is a user. So by combining like this, we can say something like select ID and then first name, right? We can use aliases now. So I'm going to put a comma here and say type, right? Now type does not exist as a column, so let's make an alias instead. We're going to say, we can say something like last name as type, right? You remember this aliasing we were doing, like so. So we select ID, first name, last name as type. Now last name is an actual column, but I don't want to get actual values. I just want the same exact value for all users in that column. So instead, what I will do is I will put quotation marks around here to make it a literal value and not a value from a column. And then here I'm just going to say user like that. Okay, so user as type, which means type is the column name, user is the data. So this is the data. This is how it always works. You can say something like first name as name, but then first name is the data, then as name is the column. Now, because this is not a literal string, it represents a column, it will get data from the column. But here when I put quotes like this, it means I want this to be a literal string there. So when I do this, now I've added an extra column here, so which means I should add an extra column on the other side as well. So here first name, and then I can do comma. Here I will say customer, because on this other side I'm querying customers, as type as well. Now I don't really need to say as type here, because what union does is it just gets the column names of the first query and completely ignores the columns from the other query. Because they are all in the same column, it doesn't really matter. It will just discard them. So here I don't really actually need to say as type, because I've already done that on the first one here. It will just get this one. But I can leave it there just to be thorough. So if I press enter, this is what I get. So you see here I have John. I know John is a user, Jersey is a customer, Dong is a customer, and so on and so forth. Okay, so that's how you combine tables with union, and you can use a little bit of aliasing to get some more interesting results over here. All right. So what can you really use this for in a real world situation? Well, this can be used, let's say for example, you have separate tables. You have tables for customers, you have tables for users that are very different, because let's say for example, users need to actually log into your system and use it, but customers don't. Those users just have a list of contacts in there who are customers, right? But then there could come a time when you want to search the whole database. You don't care whether the user is a customer or a user. You just want to find results. So this is what you can use that for. You can actually search several tables and get results like that. So here I can put a where clause. So keep in mind, this is a select statement up to somewhere here before union, right? So select up to here is a union statement, but you can add a where clause in there as well. You can put all the other bells and whistles that we've done so far. You can use regular expressions, search terms in there, and so on to get whatever results you want. The only important thing is that the number of columns is the same as the next select statement you're going to have here. So that's what it is. And then you can put these markers or identifiers in here, so we can identify where each record, where did it come from, which table did it come from. You can identify them like this, right? So with union, also keep in mind, let's try to kill this thing. Let's say for example, I do select all, right? Let's say select ID, comma, first name from users, right? But then I do a union here, and then I say select last name, comma, age from customers. This will work just fine. Even though you see here, I'm selecting an ID and first name. On this one, I'm selecting a last name and age. Totally different data from these two. But the fact that these are actually 2 columns each, this will work just fine. So if I press enter here, this is the kind of distorted result you get, because on this first one, it's looking for the ID, but then it goes ahead and looks for the last name on the second query. And then here on the second query, it's age. Here it is first name. Okay, so it won't bother to tell you these columns are different and stuff. It's up to you to choose which columns go in here. Also, the union keyword here only returns distinct values. So if there are duplicates, it's just going to ignore them. So what you should use is union or, So you can say union like this, and then you put or, right? Then it will bring all the results regardless whether they are duplicates or not, in case you actually want that. So that's how you can use that union keyword. So let's go to the next, which is joins. Let's see how you can join two tables. Instead of using union, we can do more interesting operations with joins. So to deal with joins here, let me just save what we have done using union. I don't actually have that anymore. Okay, so here we just say select all from users, union select all from customers. Okay, something like that. Just a reminder of what union can do. Okay, so we go with joins here. Now, there are several types of joins. Now, the way we combine tables in union is through columns, right? So if which means table 1 and table 2 should have exactly the same number of columns, because the joining happens with columns. Just like this, the result is just like if you did a query for table 1 and a query for table 2, and then combined them, one on top, the other one at the bottom. That's how union is like. But then a join is different. Instead, imagine you get this table and then you grab this one and then join them side by side. Instead of top down, you join them left and right. So you have twice the number of columns, which means it doesn't matter the columns, the column count of the first table or the last table. You're just joining them side by side, which means the numbers can be different. The reason why the union needs to have the same number of columns because you are combining top bottom, so there has to be a match somehow. But joins do not care about that, which is awesome. Now there are several types of joins here, and I'll show you an image over here. So there is an inner join, a left join, right join, and a cross join. Now most of the time I use a cross join. I think this is what you probably use the most, because these I find have a few problems because you have no values or NULL values in when you're requesting your data, and sometimes I don't like that. So that's why I mostly just use a cross join. So cross join is just literally combining two tables, just getting all the data from one table, combine it with the data from another table, right? Just side by side, boom, join. But an inner join, for example, is one where there's a comparison made and only records that are found in both tables are returned. Okay, so both tables, whatever matches on both tables is returned. So if there are values, because sometimes you may want to join two tables and you find that there's no match. For example, here, let's see, if I have a user ID here, right? There's only user ID 1 and 2. However, here there are many user IDs. They're up to 8. But not everyone here has a customer here. But every customer here has a user here, right? So it only goes one way. So if we start with this table, for example, we query this table, and then we say inner join this one, right? The only results that will come up are the ones, these here, 1, 2, 3. That's all. The rest will not, because they don't have any records with this one here. That's how an inner join actually works. So keeping that same thing in mind, you can see how a left join will work. A left join will bring all the records that match a criteria from the table that you've started with, and then look for ones that are intersecting, which means 1, 2, 3 here in this case, because there's 1, 2, 3 here as well, and add those as well. The right join does the complete opposite. It deals with the second table you've mentioned. So here, the table you mentioned first does matter because left and right join are based on that. So the first table this is table 1, that's a left join. Table 2 is the right join. And then intersect for both. And then this one just doesn't care, it just brings everything back. So let's see an example here. Let's start with this cross join and see what happens. Let's just say join, right? So I'm gonna say, let's go here. So I'm gonna say select all from users, join customers. So let's try this and see if it actually works. So copy that. We start with the basics, right? Select all from users, then just join customers, right? Boom. And there it is. Look at that. Now, if you've noticed, there's a lot of records, way more records than if we just combined the two, right? Here there's 8, 9, 10, 11. But looking at this, it went a little bit overboard because it just combined everything. So this is, I think this is the cross join, right? Because if I say cross join, oh, okay, no, cross join is actually slightly different, I guess. I don't know what the difference is really. Let me see here. Cross join. Yeah. Let's see what's the difference here. 3 8s here. I think it's the same thing. Join. Yeah, pretty much. I think join and cross join are the same thing. I'm not particularly sure. Yes, they are. So join, just saying join is like a cross join. Everything is returned. Now, the reason why the records are more than anticipated is because what it's doing is it's pairing this other table several times, not just one time. If you see here, there's a repeat 1 2 3, 1 2 3, 1 2 3 to match every record here to all the 3 records on the other side. This is why you see here it says John. John is repeated multiple times and then combined with the other customer. Now this looks very familiar to what I was telling you about over here, where you are matching, you're repeating the name here to match with these other customers here, right? So that's very, very similar to what's happening here. But it's just matching everyone to everyone because we haven't really told it what record to match to what. So what it does is it just go through all these records one by one, get one record from here, match it with all the records in the other table, come back here, match it with all the other records in the other table. So if you have a table with 100 records and another with 100 records, it's going to bring back 100 times 100, which is like 10,000 records. So you have to be careful when you're using this without any guards up. So what we should do is we should tell it what to match things with, right? Just by saying join is not enough. We want to tell it what part we are joining to what. So in here, I'm just going to say join customers on. So you use the on keyword there and you say users. Now we look at the users table. What on the users table? Why am I doing this? What on the users table? What's the foreign key, you know? So here we're going to say users.id. So we want to grab the ID on the users to match with the user ID on customers.user_ID. So we join customers on users.id is equal to customers.userid. So this is how you actually specify a column within a table. So you start with a table name and then a column and then a table name and then a column. Now we could just say on ID is equal to user ID like this. But the problem is this ID is ambiguous, which means the system can't really know which ID you're talking about. Is this the ID from the users table, or is this the ID from the customers tables? Because remember, there are 2 tables here involved. So you have to be very specific which column you're talking about here. Now, if both tables had very different column names, then this would be fine. It would actually just take a calculated guess. But it can't do that here because ID is found on both of these. So it's better to actually specify which table's ID are you talking about here, even though this one is more straightforward because there's only one. But that's the thing, we're telling it to match those two. So let me copy that and let's come back here and paste. Okay, so we get a much more streamlined result here. As you can see, it just went through John, and so okay, John is connected to this one and Mary is connected to that one. Let's try the same thing and say cross join and see if we'll get any difference. I actually don't know this information. This is one part I actually don't know because I never say cross join in my actual work. So it will be interesting to see the result, and it seems exactly the same. So a join and a cross join, same thing. So here I just got the first one here and matched it. So as you can see, ID is matched to user ID on here. ID on users is matched to user ID here. And again, it brings back John here and matches John to this one again, because that's how it's matching. It's just doing this. So great. That's how we do it. But let's try an inner join. So these things are the advantage, they are exactly the same. So if you find this inner join, cross join, left join thing confusing, just do a query and see what results you get for each one of them, and then you can tell whether that's really what you want. So we'll do some real world examples in what you can really use this for. Now we say select users. Now instead of cross join here, I can just say inner join, right? Inner join, everything else remains exactly the same, and we're going to see what results we get. So I'm going to copy here, paste, and boom. So we got 3 rows here. In this case, it gives us exactly the same thing, right? Interesting. So yeah, that's the inner join. In this case, our inner join is the same as the outer join because there are very few records on this side to really have a huge impact. But now let's try left join, okay? Now, as you know, left join prioritizes this table instead of this one. So let's see if we'll get any different here. Okay, so something different here for a change, right? So let me go this way. Things look weird here only because I think things started going overboard here, so they're wrapping around. But otherwise, it's pretty much the same thing. So this is the reason why I don't use the left and right joins. Which one is this though? This is the left join. So what it does is it reads from the left, gets everything from the left. That's John, Mary. You see all the records from the left side are here. From record 1 to record 8, everything is here. And then what it does, it tries to match the second table, which is the customers table. So it gets everything from the users and then does a left join, which means it prioritizes the users table. So get everything from the users table and then try to match the customers table on the right. Now, because there are no records that match this one, you see when we say ID is equal to user ID, on the customers table, there is no user ID 3, right? So which means it returns an empty result. And this is why you see all these null values on this side up to the bottom, because only these three exist on one table, but there's more on the users table. So that's why you get this kind of result. So there are situations where this is preferable to the other one. So the right join does just the opposite. So if we do here, we just say right, boom. So the right has less records. So this could be more desirable in your case if you don't want to see these null values. So that's because you start, usually the rule of thumb is to start with the table that has the lowest number of, if you want to avoid these empty values, start with the record that has the lowest number of records and then try to combine it with the one with the most. That way you know that every record in one of those, the first one you've started with, you can use a left join then, has a match in the other one, right? So in this case, this is what has happened with our right join, because the second table has a match, every record there has a match in the users table. So that's why you see only 3 records here, because those are the ones that are matching properly. All right, so this is all good, but let's look at very practical examples. So let's see here, first of all, let's have a quick reminder. I'm going to say select all from users, and then again select all from customers. Oops. Okay, so those 2 records are here, those 2 tables. Now, what if I want to do something here? I want to grab the customer, one customer here, but then I want to know which user the customer belongs to. So there's Jersey here, and I can see that this one belongs to user ID 1, which is John. Okay, but how do I represent that? And I just want to get one row. I just want one result that contains both the customer and the user in the same row, all the details in one row. Okay, so I can easily do that by just adding a where clause. Okay, so here I want to get a specific result. So I want from customers to get ID number 1. Okay, so let's do that. Let's just say select all from users. Okay, where actually before the where clause we do a join. We say join because they must be combined together before we do the where clause. That way, when we are using the where clause, we can choose whichever table to match against, whichever column in both tables to match against. Now, let me also say that you can combine more than 2 tables. Actually, you can put 10 joins. It doesn't matter. You can just say users, select from users, join customers, like that. And then you can continue, keep saying join this, join that, join this, join that. You can join as many tables as you want. However, just remember that you can say join customers and you put on like that to make sure users.id is equal to customers.user ID, like that. And then when you do another join, you say join, you can join maybe another table, maybe there's a posts table, and then you have to also say on, and then you choose 2 tables to join together, like that. You can keep chaining them as many as you want. Now, this is getting long here on the query itself. That's because the table names are long. But imagine if you have bigger table names or longer table names, this would get very bad real quick. So what you can do is you can say select all from users and use aliases and say as you, like that. So now users becomes you. And then you say join customers as C. So, or you can just say as cus, whatever it is, you can just give it a nickname. So customers is C, users is you. Then on, now since we've given them aliases, we don't have to use the real names. We can just say u.id and then c.userid. That makes it a little bit shorter than it would have been otherwise. And we are not joining anything more here, so let's do that. So we join that, but then we put a where clause and say where we want just to return where the ID here is 1. So we'll say where ID is equal to 1. Now that ID again is ambiguous because they had IDs on both tables. So we have to specify which table we are talking about. In this case, it's the customers table. So say where c.id, like so. If I press enter, I get one result as intended. Now you can see here there is John, the details of the actual now I will just be using join here, but like I said, you can use left join, inner join, it doesn't matter. Most of the time it will give you exactly the same results, especially when there's a where clause like this. But you can try each one of them until you get used to which one works in what situation, right? Because here, even if I explain, it'll just feel foreign to you. So just do some tests and see what works better. So here, as you can see, there's information from this table up to here, and then we start another ID up to there. So we've successfully brought 2 records in one row like this. 2 records in one row. At least now we know what's what. But the problem here is that, you see, first name here is just first name there as well. So this will be very difficult to actually grab the column that I want. So we need to rename some of these with aliases so that they are different completely. The ones for the customer and one for the users. Otherwise, the record was returned as needed. So let me copy this and put it where it's supposed to be, over here. Joins, right? So you can combine joins with aliases here, which is mighty awesome. Okay. Now, in order to get specific columns, we can redo this, right? But then we go back here in the star here. Instead of it returning every single record, we want to choose specific columns, specific columns to bring back. So we want the first name, the last name, but there's first name and last name in both tables. So we have to tell it what we want. So we can use ID. So let's say ID. Now we can use the aliases. Instead of saying users.id, like we were doing before, you can just say u.id because the alias still stands. So I want the ID from users, right? And then also u.firstname, also u.lastname, okay? And then comma, now I want c.firstname. Now instead of it being first name, I'll give it an alias and say has c name or customer name or something like that, okay? And that's enough. We just want the first name. Now you can combine those two. So let me do this here. Let's get a little more complex here. So I'm going to copy all of this for safekeeping here. Boom. And then let's come back here. Let's press enter and see. So we have a much shorter query here. There's customer name, Jersey, first name, last name, and so on. So this could be, we could have just said username. A better way to do it is, let me redo this query. Here what I can do is concat these two. Let's use the knowledge we've used before. So here I'm going to say concat. Okay, concat like that, bracket, and then go down here and then put comma. Let me put a space there so that between first name and last name there is 2 of these. So we concat those two, put a bracket, oops, wrong place, put a bracket, and then say as user name. Now I want this to be spaced, so I'll say user underscore name inside quotes like that. And then here we do exactly the same thing. Let's just do concat and this one is c.firstname. Let's put a comma, space, c.lastname. So it's slowly becoming very long, and then I'm going to close that and say as. Let's put bracket here, customer name, oh, not a bracket but a, oh, I already had that, right? Let me remove this other as. So let me put it in the text editor so you can see it better. So I'm going to copy that query. Boom, 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 boom. Let's go over here and let's paste. Okay, so this is how it is. Now I'm going to do this instead. It's easier to see if we do this, what we are doing here, right? Boom, boom. I don't know if this is easier to see, but this is our query. So the query says select UID. So that's from user, because the moment we see UID, we check, okay, whose alias is this? And from here, you can say from users as you. Okay, so that's user.id. Then we are joining these two. We are doing a concat. Now, concat has two functions. I didn't mention that. There's one which is WS, like that. There's concat, and then there's concat WS. Now, they do exactly the same thing. It's just that when you use the WS, if you have many values in here, because if, let's say, I had 3 names or 3 strings here, I would have to redo this part, the space part here, and then add another value and so on and so forth. So if you have many of them, you can use the concat WS and then just put this thing at the beginning like this. You put the space there at the beginning and then comma, and then now you can forget about putting the spaces after this, like so. So you can just put the space at the beginning here, or whatever character it is. You can actually put a comma here also, so if you want commas between these. Then you can just keep adding stuff in here, and it will use this in the middle of each item repeatedly. Okay, so then we put an alias here, right? And then from users as you, and then we join this and tell it which 2 values should be the same on both tables. So on the user side, ID should match the customer's user ID, and then where the customer ID is equal to 1. So we are targeting just that record with the customer ID as 1. So copy that, and let me delete this so I can just paste the one I have created. Come on, come on, come on, come on, come on, come on. There should be a shortcut for this, right? So if I press enter, ooh, wait, concat WS does not exist. Wait, what is it? It's concat. Wait a minute. You know, if you forget something, just Google it. MySQL concat something. Let's try and find it. Okay, concat. How can I forget this? You know, sometimes it's easy to forget the little things. Let me see. Oh, it's concat WS. Isn't that what I've written? Yes, it is. Concat. Let's see. Select concat WS. Yeah. Yes. So what is it talking about? Function concat WS does not exist. Okay. Maybe it doesn't on mine, so let's forget about it. Let's just edit it and use what has worked, right? Let's not worry about this stuff here. So I'm just gonna undo for a bit, and there it is. So let me not start struggling with that. So these do not exist. Both of these do not exist. No, I've used concat before. What am I missing? Did I type it wrongly? I think I typed it wrongly. So let me just put it back. Where did I use concat before? Come on back here, guys. Let's see what I did wrong. Is it the spelling that's wrong? You know, when you do something for a while, everything begins to look exactly the same. So I did use concat at some point, I know, so it should work. Wait, I didn't save that. What the? Yeah, my bad. Guess I didn't save that part. Customers, blah, blah, blah. Hey, apparently not. right? I didn't save that. Okay, so yeah, my bad. You see, there's an A here instead of an O. This is what I'm talking about, you know. I'm sure everyone was screaming on the screen, hey, there's an A there. Yeah, you know, it's easy when you're not the one doing it, right? Okay, so there it is. That's what I made, the mistake I made there. I think I'm getting tired. That's why this video is taking too long. Okay, let's go back to business, right? Paste there and press enter. And there we go. So we get a username and a customer name together with an ID there. So I can add more details here and so on to create a join like this. It's very useful stuff. For example, a real use case scenario is where you have a post, right? So you load this post, you retrieve posts for your page, but you want to also know who the user is, who the creator of the post is. So you can have, in that same row, you can have the details of the post, like the content of the post, and then you can also have the creator's details as well. That way you put them in one post at one time. So that's the use case scenario. I use joins quite a bit in my projects. So this is a good skill to have. Now, there are certain times when you want something slightly different. So let me show you how you can use aliases or how you can run queries within queries. All right, so there's also running queries within queries, right? These are called subqueries. So let's look at how to deal with subqueries. So there could be a time, for example, where you know the details of a customer, but you don't want those details. What you want is the detail of the user that created that customer or the owner of that customer. So in this case, let's say, for example, I have the name of the customer, right? But I want to know who the user is. So first of all, I can read from this table based on the name, right? So I can do something like select all from customers, all right? Select all from customers where first name is equal to, and we put Jersey there, like that. So if I want, I can say limit 1 just to get one result. Okay, good. There it is. So I have that guy. But I want to use in the same query the result of this to grab the actual owner based on the user ID. So really what I want is just the record here, but only the user ID column, and then use that to run and find an ID that matches that in the user's table. So I can combine those by creating what is known as a subquery. So let's go ahead and make this from our editor here. So these are subqueries. Okay, so this is a subquery thingy here. So I'm going to grab this, select all from customers where first ID is equal to Jersey. I don't need to limit 1, it will figure it out by itself. I don't think you can put limits in subqueries yet in MySQL. So what I want is to put this inside a bracket so that MySQL can start with this, but you don't have to actually, it will know what to do by itself, but it's always good to just do this. And then here, what I can do is, I just want one result from one column, right? So here, I will do something like, say, I want just the user ID of this thing. So keep in mind that the record we're returning here is this one, but we just want that column and discard the rest. Then this column is just one item. Then we can use this to actually run a separate query. So we can say select all from users, right, where the ID is equal to, and then we equate that to the result of this other query. So this within here is a subquery. So let's see if this will actually run. So let's save that, paste, boom, and it actually ran. Now, as you can see, we started with having a name called Jersey, but then we ended up with this result that has nothing to do with this except that ID is a foreign key, or this one is a foreign key to this one here. That's the connection between the two. So this is how you can do it. So for example, you've loaded a post in your website and you want to figure out who created this post, but you don't want to return the post content itself, just the user. You want to go to a specific profile of a user based on the name of the customer, right? Maybe there's a name of the customer in the search, and then you want the result to be, instead of that customer you search for, you want the one who created that customer. And this is how you can return that result. Okay, so well and good. Now I'm returning this. Now this will work just fine, but let's twist it a little bit so that we see what errors can come up. So let me duplicate this. That way you know how to solve them. Now, when you're dealing with, I forgot to mention, with joins here, if you get an error that says, oh, this thing is ambiguous, it simply means whenever you see the word ambiguous, just know that you are specifying a column without specifying its table. That's a very common error, so just a heads up there. If, for example, here I just said ID, I'll get that error that says, oh, that ID column is ambiguous. I don't know which one you're talking about. Then you can go in and specify the table plus the column. Okay, so in this case here, this is working because this is returning one result only. But what if it returned more than one result? What happens to the equal sign here? So I can just say where ID is greater than 0, because I know when I say ID is greater than 0, there will be more than one result. So let's see if it can handle that. So if I paste this here, then I get an error. And look at the error that says subquery returns more than one row, and that's a problem. So when it returns more than one row, just know that you will have a problem. But you can solve this problem by just putting the in function here like that. Because remember that in gets an array of results, right? Just like we were doing previously, where we say ID in, and then we put several items there. This looks like the perfect way to use it, right? So I can grab this and paste that in, and look at that. Now we get more than one result because it's looking for all the results that match a specific criteria, and it finds. So it brings us all the users that have a customer whose ID is greater than 0. Okay, so there are only actually 2. Now the reason it's bringing 2, even though there are actually 3 records in the customers table, is because these 2 are repeated. They have the same user ID, right? So I guess that's why. Where ID in, right. Yeah, so this is wrong actually. We should, to get all of them, we should use user ID here, because in customers we're just saying where user ID is greater than 0. Yeah, this will get us all the results we want actually. So let me copy this, because the other one was using ID, and then ID only has, wait, where ID in, okay, user ID had 1. Okay, yeah. I don't know. Let me try it instead of speculating. No, we still get the same result. Why is that? John and Mary. Oh yeah, because John and Mary, exactly. There are only 2, 1 and 2 in here. In the customers table, user ID is only 1 and 2 here. 1 and 2. So when we say in, this is the data that we are getting, and so if ID is 1 or 2, so it just brings 2 results. Okay, so that works. That's a subquery. Now there's a different place you can put a subquery. Now also keep in mind that you can put a subquery within a subquery within a subquery. So you can keep going deep down Like for example here, instead of saying where user ID, you can say also user ID in, and then actually put another select statement down there. You can keep going inner and inner and inner like that until you get to the one you want. I often do that whenever I'm creating something like a social website, because social websites are very complex. You find that you need very specific data from using very ambiguous data. So you may have to go maybe 4 subqueries deep to just get what you want. So you will find use cases for this kind of thing eventually. So just know that you can nest these subqueries as many as you want. So this can be a result of a subquery, and inside that subquery could be another subquery there. Okay, great. So let's see where else we can put a subquery. Now a subquery can also be added right about here. Okay, so let's see how that could actually work. So let's say, for example, here we have those 2 tables, right? So let's do again select from users, right? So we say selector from users and customers so that we can see the tables. Now really what I want to do here is, let's say I have what we were doing before, right? I have this here. I just want this one row. But instead of user ID, on this column, I just want one column with the user first name here. Now, I can do this with a join, no problem, because I can just join this other table here and put it here, put that one column data over here, quite right. But maybe you don't like joins for some reason, right? You can instead use this column to create extra columns. So what we can do here is this. I can say select all from customers, right? Let's just get one row. We say where ID is equal to 1. Okay, so very good. We've done that. Good. We'll get just that one row. But here what we'll do is we have a star there that says select all columns, right? But then we can put a comma there and then just add an extra column over here. So instead of just putting a column here, we can actually put a whole select statement in there as well. But then we give it an alias as first, or just say customer like that, okay? As customer, so that it comes back as customer. Otherwise, if you don't put this alias, it's going to put the query as the column name, which is insane. Okay, so what we'll do is in here, we'll put a query and say select. Now always keep in mind that the result from here should be just one row. This is, otherwise it will break down like the other thing. So you should just always make sure the query you're running will return one row. So that's why it's a good idea to reference the ID, because it's always unique. And then mention just one column. So I want to select first name only. That way it's just one column and one row result. So select for first name from customers. Oh wait, no, from users, sorry. First name from users where ID is equal to. Now this is an important bit. So ID is equal to what? Now I want to have my ID equal to the customer user ID. So here I can say customers, sorry about that, dot user underscore ID. Okay, let's try this out. Oh, sorry, a non-column customers.user customer.user ID. I forgot an S there. So let's come back here. It's customers, and there we go. So look what we have. Oh, it's supposed to be user.customer. What the keep making mistakes here. Okay, so let me just copy this. That's why this other text editor is better. Let me paste here. So this is how the query kind of looks like. So here we're replacing this part here with an actual result and then calling the column customer, but we should call it user actually. So let me undo that and let's copy this. Let's paste it there and press enter. So there we are. Now we get a result which has our customer, but then with that user's name that they belong to. Now, if it doesn't find the result here, to just put a no. So we can see that by saying, if we say where ID is equal to customer, let's just put ID is equal to 100 because we know that does not exist, right? So we can just put it on a very specific number like so. And then it doesn't cause an error if it doesn't find the result. It just puts a no there like that. Very nice and quiet. But otherwise, this is how you would do it. So you can leverage the information from this table you're reading from and then put these directly in the select there, right? So this that we've done here saying select blah 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 as this, you can actually put a comma and put a second one as maybe age or something, and then put another select statement. You can put as many select statements as the columns you need of information from other tables. So this is like joining other tables, but just joining within the select here, within the columns here. So that's another way of doing things, which is very neat. I use this sometimes as well. If I just want just a small piece of information from another table, I don't want to create a whole join just to do that. I can just run a select statement within here like so. All right, now let's look at the having keyword. So there's a keyword called having like that. Okay. Now this one was introduced because the where clause cannot be used with aggregate functions, right? So let me give you a simple example here. Let's say I want to run a query that counts that counts the edges and then groups by age. So let's see how that would come out. We can have something like select or select count like that, star, as total from users, okay, and then we say group by age, okay, something like that. So what I'm just trying to say here is that count everything and put the column name as total from users. So count everything inside users, but instead of just counting every single record, what I would do is group them by age. So each age give me how many items are, how many records have that age. So if I do this, this is what you see. So you see 1, 1, 1. Now this doesn't make much sense. So what we're going to do is we're going to put age over here. So the count as total, but let's put age at the beginning. We'll say age and then comma like that. Okay, so at least now we can see that there are two people with the age 30. You see, there's two people here. There's one person with 20, another person with 24, but 30 has two people. So this is how you can count if there are any duplicates, duplicated information in your table, for example. You can use this formula to do that. Now, what I want here is that I want to run a where clause and just return where there is 2. So I don't care about where there is 1 item here. I just want to see where there's a duplicate, right? So which means because there could be thousands of records and I don't want to return all of them, just the few that are duplicated. So this becomes a problem because now what the reflex is I'm going to run to the where clause, right? Of course, because the where clause should do this. But the thing is, you can't put the where clause before the group by. Group by comes first. If I try to say where age, or where total, for example, where total is greater than 1. Let's try that. So if I press enter here, it tells me unknown column total. Okay, fair enough. Let's get back here. Let me undo this. Okay, but then if I go group by and try the where clause over here, because after it groups them, I'm thinking, okay, after it groups them, there should be a total column there, right? So total is greater than 1. It gives me an error. Okay, so that's because the where clause actually runs before we group the items. So the where clause should be before group by here. So we run all those queries with a where clause, and then we group the result. This is what happens. Now the problem with that is I can't run queries like this because the grouping happens after the where clause has already gone by. So I can't then say where this new column is to, because that where clause would have been done by the time we get this result. So this is where the having keyword came from. So having is like a where clause, but for when you use these group by aggregate functions. So in here I can just say group by age, right? And then say having total is greater than 1. Look at that. So having works wonders because now the total column actually exists by the time we are running the having keyword, because the grouping has already been done. So that's why it can actually see, okay, there's a column there, because it creates a temporal table, or what is known as a view, for the results here, and then it can actually query that one more time. So it's like it does a query here of a group by and then continues to do another query on that result and to just get the one that you want, like this. This way you can return only the records that are duplicated in your table if you want to. So that's what the having keyword does. All right, so let's look at dates and time here. So dates, okay. But before that, actually, let's look at the, or we can do that later. We'll look at the between. Okay. All right, so let's look at dates here, and then we can call it a day. So in MySQL, there are date functions that exist. So there is date time, something like this. Let's see here. There's date time, there's timestamp, there's also now, there's also time, there's day, there's week, there's month, of course, and year. So all these are functions you can use to manipulate dates and so on. There's also interval, like that. So let's see how to use these things here. So if you just say select like this, and then you can use one of these guys, like you can say select now, and it can actually show you the current time, the current date. So we can copy this and go to our thing here and just say select now, and that's the current time here and date. So let me add a column on here onto the users table. So we can say alter table users, and then we want to add a column called date created, or we'll just say call it created, like that, to show us the date when the user was created. So we'll say add created, and this one will have, now you can use date time like this if you want to set both the date and the time of when, if you want to make sure that you have the time to the very second of when that thing happens, then you can use date time. But if you just want the general day, you can just reduce that to date like this. So it's up to you, date time or date. So let's put date time in our situation, right? So we have created date time here, and we don't need to specify. Created is the name of the column, date time is the type of column. We don't need to specify the length here, but we can put a default value here and say default. So that way when you add a new record, it can save the current time when the record was created. So you can say default now like this. Okay. Now there's a caveat here I have to tell you about, and this is that when you edit the table, you edit a row, it will actually replace with a default time. So this is why I normally don't use default time like this. From my experience, when let's say a user signs up today, it will save that time, but then when you edit the record, it will actually change that value to something else, which might not be something you want to do. So just give it a test and see what happens. But in this case, let's see if this will actually work out. And let's allow it to have no values like that. Okay, so now let's do select all from users. So there it is. It has given us exactly the same second when everything was created. Okay, cool. So now if we add a new record, let's add a new record, right? Let's say insert into users. Now here I want to provide also the key, the ID there, and say Jude Pope or something, and then the age, let's replicate maybe 60, and then we have test here. Oh, why am I putting values here? So test will be equal to 0. It's not something we should even have. This column should be gone. And then created, we won't put anything. So we just want the created thing to be, I think in this case we have to specify the column names. So insert into users, here we'll say values, and then here let's specify the column names. So we're gonna have first name, last name, age. We didn't specify a user row, right? It has user as a default, so I think that's fine. And then we have age, and then nothing else. So let's just put those 3 as data points and then press enter. Okay, then now we can select from users and see that we added one more record, and we didn't specify the time, but it actually did put the correct date and time here, which is cool. So that's how you can do it. Now let's try and edit record number 1. Let's see what happens. We say update users, set first name, or let's just set age is equal to 31, where ID is equal to 1. Let's see what happens there, and let's check out our record. And it actually didn't edit the date. So I think when I had this, I've had this phobia for a very long time, and it was probably unfounded because it actually doesn't do that. As you can see, this has maintained even though I've edited something there. So go ahead and use the now if you want as a default value for your records here. It saves you some time instead of having to do these things yourself. Now, you can also read, if you want to read a specific record based on date, you can use several methods, right? So here, let's say, so here what we want to do is I want to read all records that were done in 2023. So I can say select all from users, okay, where, now the thing is here, you have to use the functions now. So these are the functions here. Let me come back here. So you can, we've seen how now can be used. Now can be replaced by instead of using now like that, you can say current timestamp. It's the same thing like that, right? So if you put current timestamp like this as a default value, it will do pretty much the same as now. So just to keep in mind there. And then so here I want to use year. So when I use year, I can use month, week, and day in the exact same way, and time as well. So here, let me go back here. You see, if I say where year, and then I wrap the column within it, the column for the date is created is equal to, and then we can say 2023 like that. Okay, and then it brings me all the records. Now if I don't do this, if for example I just say created is equal to 2023 like this is not going to work. It will return empty result. So I have to tell it that within that column I just want the year. Just compare the year by itself. And this you can actually do with all the others. We can say month in the same way. Okay, now you can combine these and say, for example, month is equal to that, and then you say and like that, and then you say the year, same column again, created is equal to 2023. So both must match. We need the same month. Now this will return no result, and don't forget to close that, because there's no month 2023, but there's a month 10 like this. If I press enter, it gives me the results I want. Let me change the month to 9 or something, or 8. Then I get no results, as you can see. So just make sure, because it's very tempting to say you want to grab an item from this month, right? Like last month, let's say in June, but you have to be mindful that you are in a specific year. If you don't specify the year, then it means next year the records you are getting in this June, you also get those records next year. So it's a good idea to start with day. If it's the specific day you want, you say day, wrap that, and then put the day, and then month, and then year. So you put and for all of those, right? So very important. Now also, if you, let me see here, you can also use time here, hour and minute actually, if you want to. So where hour like that, so the current hour here is, there was 14 and then there's 15. So let me try 14, hour created, and then we say is equal to 15, right? So there's only one record with hour 15 here, and you can see. So you can do exactly that with even second and minute and so on. Or you can craft the entire time here. You can say time is equal to, now you might want to put this in quotations. So I want the time that is 14:59, right? Now, if you don't want the whole time, you can specify, you see, there we go. Let's try the same thing without specifying the second. We don't get any results. So it has to be very specific. If you want the exact second, you can use second, hour, minute, just in the same way. Now, if you want to arrange, you can use the between keyword, which is what we're going to see a bit later. So we're going to see that example very soon with a between, but at least now you can see, you can grab this range. You can use also ranges here with, let me go back a little bit. So you say month created, you can say month is greater than, you don't have to just use the equal sign. You can say month is greater than 10, and again you go month created is less than 20, even though there's no month like that. But then this will give you results between 10 and 20 of a month, right? So this could be 12. Let me just put 12 there so that we are within reality. So this will give you records that were done in the month of October to December, something like this, right? Now it would be good to have year as well here, so you can put year and month like this. Okay, so that's how you deal with date and time. So whenever you set the column to date instead of date time, here we've set it to date time, that's why we get all that. If you just set it to date, you get only this. Date time, you get all of that. So it depends what you want to do with this. Okay, you can also edit formats here, but I won't do that because normally we do that in our coding language, which is PHP. It makes things much easier. Now let's finally look at the between here. Now between uses a let me copy these first of all. Sorry about this. That way you can see examples of what we've been doing here. There's time. Actually, this wouldn't work, so let's put this one. Okay, copy that. Let's get one more that has a year. Something like this. Oh, that one has year. Okay, so that's great. There's also week as well, so you can use week and so on and so forth. So experiment with those things and see what you can come up with. These actually should go up here. Okay, so this one is for selecting a range. So you can use between for searching. So for example, let's go back to our table here. Let's say I want to search for people with an age between 20 and 30, right? So in this situation, I can do select all. Let me cancel all of this. So I can do select all from users where age between 20 and 30, just like that, and you get them just like that. So these guys are between 20 and 30. Now the between is inclusive, so if there was a value of 20, it would also show, and 30 would also show. As you can see here, 30 is included in that list. It's as simple as that. I can do this and go maybe ages 10 to 20, which there's only one, which is at 20 itself. Okay, now you can also use a range of dates and a range of names, for example. So here, if we do select all from users, we can search by a range of text. Let's say, for example, I can say select all from users where, let's look at the first name. So we say first name is equal to, or between, sorry. First name between A and D. Like that. Now these have to be inside quotes because this is text. So let's put those quotes around there. So that's what we get. We get a B. What about if we go between F and X, maybe? So those are all the names between F and X. So what it's looking at is sorting in alphabetical order here. I think it just looks at the first letter here, especially here. Now, if I get this same thing and just put some gibberish at the end here, just like that, right? And I go to F and some gibberish, maybe even throw in some numbers there and so on. If I press enter, it will still give me the same result because it doesn't really care about the other text here. It just ignores the rest. It'll just grab the very first one, compare it in alphabetical order, and that's about it. So that's what it does when it's text. But you can use that to search between a certain range. So same with numbers, same with letters. you can also do the same thing with date. So you want to search between a specific date and a specific date. So here I can say between 2023-10-20. No, yes. So since it's inclusive, we should get all the results here, right? 2023-10-20. And we get nothing. So why did we get nothing? Well, that's because this is date time and not date. So it has to take into consideration the time as well. So if we don't want that to occur, we can use those functions like date. Okay, date created. So created is the column, and date means, let's convert that into just a date. Is it between date? Oh, wait a minute. Will this actually work? Where first name? Oh wait, I think why it didn't work is because we are searching in first name. Okay, so let me, before I dismiss this here, my query was completely wrong. Let me do this. Oops, there we go. So instead of first name here, it should be created. So we still get an empty result as I thought, but now at least we have the correct query. So here we're gonna say where date created, like that. Okay, so we convert just the column into just a date without the time, and then we search with those, and now we get an actual result, which is awesome. So that's how you can still search for just a date where there's all this information within. But you can go a step further, and instead of saying date, you can say time, right? Or you can say day, like this. You want a specific day between 10 and 20. Now, usually the rule of thumb is that you start with the lower value and end with a bigger value. So here it's the same value, so it's acceptable, and there it is, right? You can get between those and those, like that. So that's how the between thing works here. To search for a range, you use the between keyword. So let me copy that in there so that you have this information when you want to do your own thing and compare your queries to this. So I'm gonna grab that, copy, and paste. Alright guys, so this actually wraps up our tutorial on MySQL. Now hopefully you've learned something throughout all of this, and if you want me to make a part 2, because there's so much more to learn, but it's just so complex and the video is getting too long, so we must end here. If you can master everything I have said in this tutorial, you'll be a master at MySQL, because most of what you'll be doing is this. The other exotic stuff you won't do very much. So hopefully you've learned something, and I will see you in the next video. Please give the video a like or a thumbs up if you like it, and please subscribe. I rarely say subscribe to my viewers, so please hit that subscribe button if you already haven't, and like the video.